I'm Kenan Thompson, but I play Fat Albert in the live-action film based on Bill Cosby's hit show. On this episode of NASA Connect, you'll learn about the science concepts of work and energy. You will also see how we can use algebra to help explain both concepts. NASA engineers and scientists will introduce you to exciting and innovative space propulsion technologies of the future. And in your classroom, you'll apply your math and science skills by conducting a really cool hands-on activity. So stay tuned as host Jennifer Pulley takes you on another exciting episode of NASA Connect, Rocket to the Stars.
Jennifer Pulley, and welcome to NASA Connect, the show that connects you to math, science, technology, and NASA. Imagine it's the year 2040. You and a team of international scientists are part of the exploration crew that will begin construction of the first human base on Mars. You are laying the groundwork for the next generation of explorers to explore Mars and beyond. It's not an easy task, but you are up to the challenge. All your years of schooling, training, and hard work have finally paid off. Does it sound like a fantasy to you? Actually, it's not. NASA is ready to make the next step to exploring the solar system and beyond, and they need your help. NASA is looking for bright, young engineers, scientists, and researchers who will make the new vision for space exploration a reality. For you, it starts right now, in the classroom. Now, during the course of this program, you will be asked to answer several inquiry-based questions. After the questions appear on the screen, your teacher will pause the program to allow you time to answer and discuss the questions. This is your time to explore and become critical thinkers. Students working in groups, take a few minutes to answer the following questions. 1. What comes to mind when you think of work? 2. How are work and energy related? 3. What are some forms of energy? Briefly describe them and give examples of each. It is now time to pause the program and answer the questions. So guys, how did you do with the questions? Great job. Okay, let's get started. So, what is work? Well, most people would say they are working when they do anything that requires a physical or a mental effort. Now, in scientific terms, work is the use of force to move an object a certain distance. More specifically, to do work on an object, some part of the force you exert must be in the same direction as the object's motion. Let's look at the following two examples. On the left side, Norbert is lifting a stack of textbooks from the floor. And on the right side, he is carrying the stack of textbooks. Note the direction of the applied force and motion for each example. In which example is Norbert actually doing work? If you said the left side, you are correct. Why isn't Norbert doing work in the example on the right? Well, because no part of the applied force is in the same direction as the object's motion. When the force is in the same direction as the motion, we can determine the amount of work being done on an object by multiplying force times distance. What are the units for work? You know that force is measured in newtons, and distance can be measured in meters. The product of a force measured in newtons and the distance measured in meters is a measurement called a Newton meter, or the joule. The joule is the standard unit used to measure work. 1 joule of work is done when a force of 1 Newton moves an object 1 meter. Do you have any idea how much a joule of work is? I I know. Let's take an apple, which weighs about 1 Newton. Now, if you lift the apple from the floor to your waist, which is about 1 meter, you do 1 joule of work on the apple. But what happens if I want to lift 100 apples? For me, that would take a lot of force, and I don't think I have enough energy to do that. Let's go back to our example with the apple. Now, I easily have enough energy to lift this apple from the floor to my waist, and I know I'm doing work on the apple as I lift it. So there must be a relationship between work and energy, right? When I lifted the apple from the floor, I caused a change. In this case, the change is in the position of the apple. An object that has energy has the ability to cause change, or the ability to do work. When I worked on the apple, some of my energy was transferred to the apple. You can think of work then as the transfer of energy. As I lifted the apple from the floor to my waist, the apple gained energy. You know, guys, energy has many forms, and we'll get to your list in just a few minutes. But first, let's focus on 2 forms of energy: potential energy and kinetic energy. Let's take a look at each. If I hold the apple still in my hand, does the apple have energy? Careful, not all forms of energy involve movement. Well, this apple has stored energy. We call it potential energy. Holding the apple like this gives the apple the potential to fall to the ground. Now, if I release the apple falls. The potential energy changes into kinetic energy. It is pretty obvious when an object has kinetic energy. As long as the object is moving, it's said to have kinetic energy. What's more difficult to determine is how much potential energy an object has. Let's go back to our example with the apple. The potential energy of this apple really depends on height. How high or low my hand is from the ground. We call this type of potential energy gravitational potential energy. Gravitational potential energy depends on mass, gravitational acceleration, and height. Near the Earth's surface, gravitational potential energy, or GPE, is equal to the product of mass, gravitational acceleration, and height. Remember that G is the acceleration caused by Earth's gravity, which at sea level equals 9.8 meters per second squared. Let me show you an example. Suppose a satellite has a mass of 293 kilograms, and we lift it to the top of Mount Everest. What is the gravitational potential energy of the satellite? Well, what do we know? We know mass is equal to 293 kilograms. Gravitational acceleration is equal to 9.8 meters per second squared. And we know the height of Mount Everest, which is approximately 8,850 meters. Let's write the equation for gravitational potential energy. GPE equals mgh. Substituting in our values for mass, acceleration due to gravity, and height, we get GPE equals the product of 293 kilograms, 9.8 meters per second squared, and 8,850 meters. The answer turns out to be approximately 25 million. Don't forget, I need to assign a unit to that number. Units are very important when explaining scientific concepts. Do you have any idea what the unit for energy is? Let's figure it out. The original equation for GPE is mgh. Mass times gravity is equal to weight, and weight is measured in newtons. Remember, weight is a force. Therefore, the unit for gravitational potential energy is the Newton meter. Do you remember from earlier in the program what a Newton meter is equivalent to? Well, if you said 1 joule, you're on the ball. 1 Newton meter is equivalent to 1 joule. Wait a minute. Work is also measured in joules. I think we just showed mathematically how energy and work are related to each other. Now let's go back to kinetic energy. How much kinetic energy do you think an object, say, like a rocket, depends on? The kinetic energy of an object depends on both its mass and its velocity. The mathematical relationship between kinetic energy, mass, and velocity is Ke equals 1/2 mv squared. Notice that the velocity is squared in the equation. Remember, guys, the number 2 is called an exponent. The exponent tells you how many times a number or base is used as a factor. For example, 2 squared is equal to 2 times 2, which equals 4. 3 squared is equal to 3 times 3, which equals 9, and so on. The term v squared equals v times v. So, are you ready to try a problem involving kinetic energy? Here's one for you. Norbert's Mars rover, with a mass of 210 kilograms, is traveling on the surface of Mars at a speed of 6 meters per second. Zot's rover, with a mass of 170 kilograms, is traveling on the surface of Mars at 8 meters per second. Predict which rover has more kinetic energy. Then verify your prediction mathematically. You may now pause the program. So did you make the correct prediction? Let's double check your work. Solving for the kinetic energy of Norbert's rover, we have kinetic energy is equal to 1/2 times 210 kilograms times 6 meters per second quantity squared. The kinetic energy of Norbert's rover is equal to 3,780 joules. Solving for the kinetic energy of Zot's rover, we have kinetic energy is equal to 1/2 times 170 kilograms times 8 meters per second quantity squared. The kinetic energy of Zot's rover is equal to 5,440 joules. So, comparing the two values, we see that the kinetic energy for Zot's rover is greater than the kinetic energy for Norbert's rover. We now know that an object may possess both kinetic energy and potential energy at the same time. Let's go back to our example with the apple. Any object that rises and falls experiences a change in its kinetic and potential energy. Let's look at this energy transformation as I toss the apple into the air. When the apple moves, it possesses kinetic energy. As it rises, it slows down. Its kinetic energy decreases. Because the height increases, its potential energy increases. At the highest point, the apple actually stops moving. At this point, it no longer has kinetic energy, but it has maximum potential energy. As the apple falls, the kinetic energy increases and the potential energy decreases. No matter how energy is transformed or transferred, all of the energy is still present somewhere in one form or another. This statement is known as the law of conservation of energy. As long as you account for all the different forms of energy involved in any process, you will find that the total amount of energy never changes. In other words, energy cannot be created or destroyed. It just changes form. So, do you think you have a pretty good idea of what work and energy, specifically potential and kinetic energy, are all about? Well, good, because now it's time to preview this program's hands-on activities. The NASA Explorer School students from Martinsville Middle School in Martinsville, Virginia, will preview this program's hands-on activity.
Hi, NASA Connect asked us to show you this program's hands-on activity.
In this activity, students will do an inquiry investigation on the relationship between the height from which a marble on a ramp is released and the distance a milk carton at the end of the ramp is moved along the floor after the ball collides with the carton.
You can download a copy of the Educator's Guide from NASA Connect website for directions and a list of materials.
Before you start the activity, your teacher will ask you to answer and discuss several critical thinking questions based on the experimental setup. Set up the ramp by using tape to mark one end 0.7 meters high and place an empty milk carton at the other end of the ramp so that it will catch the marble after it rolls down the ramp. You will roll a marble from 5 different measured heights. Line up a meter stick on the floor along the distance that the milk carton will travel after being hit by the marble. Starting at the first height marked on the ramp, release the marble down the ramp. On the data collection chart under Trial 1, record the linear distance that the milk carton travels after the marble hit it. You will conduct 4 more trials. Record the distance the milk carton travels. Calculate and record the average distance the milk carton traveled. Continue the experiment by increasing the height from which you drop the marble by 0.1 meter each time. Students will analyze their data by calculating the potential energy that the marble has at each height and the kinetic energy that the marble has at the end of each roll. Now is your chance to put your algebra skills to the test. Keep in mind that for this activity, you will need to ignore energy lost because of friction. Based on the data you collect, you will graphically show the relationship between the height from which the marble is dropped and the distance the carton is moved. From the graph, select another designated height and predict how far the milk carton will move if the marble is released. Go ahead and test your prediction. Were you correct?
Don't forget to check out the web activity for this program. You can download it from the NASA Connect website.
Now that you have a basic understanding of energy, let's hear about some innovative propulsion technologies that NASA is developing for future space exploration. And don't forget, you are the future explorers.
Thanks, Jennifer. Space is big. Distances to Mars and beyond are so large that when using today's spacecraft technology, we can only send relatively small spacecraft. In other words, distance affects the mass that we can send. NASA is working on a new way of powering space vehicles that will enable us to send more complex spacecraft to Mars, Jupiter, and beyond, and may even shorten the travel time. The new program is called Prometheus. It will provide a giant leap in our ability to explore our solar system. The program focuses on using nuclear power in long-distance spacecraft. The nuclear power system will create electricity that will be used for 2 things. One job will be to propel the spacecraft. The other will be to provide power for the instruments on board. This capability will let NASA send spacecraft to places that we currently want to reach. It would also allow us to do more scientific work when the spacecraft reaches its destination and could even help speed up travel through the solar system. Many space missions have used nuclear power. The farthest known man-made object is the nuclear-powered spacecraft called Voyager 1. This probe has been used for over 26 years. It is now over 8 billion miles away. That's more than twice the distance from the Sun to Pluto. Remember, earlier in the program, Jennifer asked you to list some forms of energy? On my list, I have mechanical energy, thermal energy, chemical energy, electromagnetic energy, and nuclear energy. Project Prometheus will be using nuclear energy to help power the spacecraft. Nuclear energy is the energy stored in the nucleus of an atom. In a nuclear reaction, a tiny portion of an atom's mass is turned into energy. Scientists are studying 2 different ways of using the energy stored within the nucleus of an atom. The first approach is to take an atom that is naturally very unstable which means that the atom wants to change into a different, more stable atom. During this change, the atom releases tiny particles causing the material to heat up. This process is known as radioactive decay. The released particles are called radiation. The heat that is released can be harnessed and converted to electrical energy. This energy can then be used to power the spacecraft systems. It is called radioisotope decay. The second approach is to break apart the nucleus of the atom to release even more energy than radioactive decay. This process is called nuclear fission. It is used in nuclear power plants all around the world to produce electricity. Nuclear fission systems can generate large amounts of power. Think of this comparison. A radioisotope power system could create enough power to light a few light bulbs. A nuclear fission power system could create enough energy to power a laundromat. This increased amount of energy means that a nuclear fission energy system could do more than just power a spacecraft's scientific instruments. It could also be used to run the engines that propel the rocket. NASA hopes to use this technology soon. In fact, it's already working on the first probe to use this technology. This probe is the Prometheus 1 mission. This mission will use a nuclear fission system. This system would provide energy for both spacecraft electrical power and propulsion. Prometheus 1 would orbit 3 of the larger moons of Jupiter: Callisto, Ganymede, and Europa. Europa is one of our solar system's most fascinating celestial bodies. Europa's surface is completely covered in ice, but scientists believe that the solar system's largest oceans could be hidden under that ice. If oceans are indeed present, there is a possibility that life could be found there. The Prometheus 1 mission will be finding answers to the mysteries of these moons. One day, the same power and propulsion systems used on Prometheus 1 could be used to send probes to other far-off places. These systems will even be used to support human missions to explore the solar system and beyond. Back to you, Jennifer.
Thanks, Anita. Sounds pretty cool. You know, NASA is working on another propulsion technology. It's called Vasimir. Dr. Franklin Chang Diaz can tell us more about that technology.
Thank you. My name is Franklin Chang Diaz, and I'm an astronaut and director of the Advanced Space Propulsion Laboratory. I would like to share with you another possible advanced space propulsion technology that we've been working on for many years. It is called the Variable Specific Impulse Magnetoplasma Rocket, or Vasimir for short. This new engine would allow for much faster space travel than what we can do today. Vasimir is a plasma-based propulsion system. Do you remember the 4 states of matter? They are solid, liquid, gas, and plasma. You can go from one state to the other by adding or subtracting heat from the material. Take water, for example. Its solid state is ice. Add heat and you get liquid. Add more heat and you get gas or vapor. If you add even more heat to the gas, the atoms in it get torn or broken. Remember, each atom is sort of like an egg. It has a central nucleus, the yolk, with positive particles in it called protons, and a blanket, the white, of negative charged particles called electrons in it. When the atom gets torn, these charges are free to roam around every which way. Scrambled eggs. Such a mixture of charged particles is called plasma. Plasmas are very hot, with temperatures of hundreds of thousands to millions of degrees. The sun and the stars are made of plasma. Plasmas are very good conductors of electricity, and they respond very well to electric and magnetic fields. We use these properties to heat them and also to confine them and use their extreme heat to produce awesome rocket propulsion. Electric fields heat the plasma and speed it up. Magnetic fields direct the plasma in the right direction as it is pushed out of the engine. This creates thrust for the spacecraft. Possible fuels for the Vasimir engine could include hydrogen, deuterium, helium, nitrogen, and others. The use of hydrogen as a fuel for the project would also have other benefits. Hydrogen can be found all throughout space. This means we are likely to find plentiful supplies of fuel everywhere we go, and we could refuel the spacecraft for the return trip to Earth. Also, strong magnetic fields and liquid hydrogen make for great radiation shields. This means the hydrogen fuel for the Vasimir engine, as well as the magnet technology we are developing for it, could both also be used to protect the astronaut crew from dangerous radiation exposure during the flight. This is how technology developed for one thing can also be used for another equally important purpose. To heat and accelerate the plasma in deep space flights, Vasimir will use electricity from nuclear power. Vasimir is still years away from transporting humans and cargo to Mars and beyond. Remember the scenario that Jennifer gave you at the beginning of the program. Our team can only take this advanced technology so far, and then it will be up to you. Your generation will make this space propulsion system a reality. Some of you may one day fly on it and become the astronauts that will build the first base on Mars. I've been in space 7 times, but you will be the astronauts who will get a chance to explore the moon, Mars, and beyond. You are the next generation of explorers. So, good luck. Back to you, Jennifer.
My thanks to Dr. Chang Diaz. You know, I can't wait for the day when we receive the first transmission from people on Mars. And maybe you'll be one of them. Well, that wraps up another episode of NASA Connect. We'd like to thank everyone who helped make this program possible. Got a comment, question, or suggestion? Well, email them to connect@lark.nasa.gov. And don't forget to check out this program's Student Challenge. You can find it on the NASA Connect website. So until next time, stay connected to math, science, technology, and NASA. And maybe we'll see you on Mars.
Did you know the largest source of water pollution today is stormwater? As rain lands on our rooftops, lawns, and pavement, the water picks up whatever debris and pollutants may reside there. Pesticides, animal waste, salts, oil, and litter.
This stormwater runoff flows into the storm drains where it travels through underground pipes that in most communities leads directly to the ocean. In our community, it takes just 15 to 30 minutes for runoff from your driveway to reach the ocean with all the pollutants it picked up along the way. But it doesn't have to be that way.
When rain and stormwater are allowed to enter the ground, the earth is able to filter out most pollutants naturally.
By the time it does reach the ocean, it's not only cleaner, it's cooler, and there's less of it.
That's better for the fish, better for the invertebrate that fish eat, and better for the plants that live in and along the water. It's also better for humans and property, as flooding and related problems are less likely. And it costs a lot to create and maintain the cement stormwater infrastructure. So any steps to address water pollution in our community will make better use of our public funds. The key to cleaner and healthier water and more sustainable communities is to capture rain where it falls by helping it drain into the ground as nature intended. We can do this through things like rain barrels, rain gardens, porous pavement, or just by limiting the amount of dense and impenetrable surfaces in our community. More green space, less asphalt and pavement. Brought to you by your local community and the Massachusetts Greenscapes Coalition.
Learn more about what you can do at greenscapes.org.
The Tennessee Stormwater Association is committed to helping protect and improve the quality of the waters of Tennessee. Over 2,500 years ago, poet Lao Tzu wrote, "A person of great virtue is like flowing water. Water nourishes all things without trying." Water has always been at the center of our cities and societies. It's a requirement for human life. We need a consistent source of water, but not so much that we have flooding. We need our water to be clean enough to treat for our day-to-day use and to support healthy fish and wildlife populations. These needs are often referred to as quantity and quality. Managing water quantity helps protect homes and businesses from damaging and costly floods. As cities and towns grow, fields and forests are replaced with buildings and roads, which cause rainfall to concentrate and rivers to rise. To help creeks and streams handle the extra water, stormwater management can reduce flooding and protect residents from danger. Waters with poor water quality aren't just an eyesore. Contaminated waters can present serious health risks. They can contain substances such as E. coli and heavy metals. Poor water quality can result in fish kills and closed beaches. They're also costly. It takes time, energy, and money to treat these waters before they flow to our taps. Cities and counties may also face fines from state and federal agencies if the water quality problems are serious enough. The waters that surround us reflect who we are and what values we hold. It's our responsibility to care for them as best we can. You can learn more about stormwater runoff by visiting our website, tnstormwater.org.
Hi everybody, my name's Alex Stark and I'm the Stormwater Coordinator for the City of LaVergne. And now you might be wondering what the word stormwater means. And today, during this video, we're going to learn about stormwater and lots more. So let's get started. Today, we're going to learn what is stormwater? Where does stormwater go? Can pollution get into our stormwater? And how might pollution or polluted stormwater affect our waterways? How can we help to protect our waterways from polluted stormwater? Stormwater is just water that flows over the ground after it rains, and you may have seen it look like this. Have you ever wondered what happens to all of that rainwater after it falls? Well, the answer is right here in front of us. To learn about where stormwater goes, the first thing that we need to learn about is a watershed. And a watershed is just an area where water sheds into one place. For example, anywhere that it rains on any of these mountains will flow into this river, and anything on the ground can be brought with it. The City of LaVergne is in the Stones River watershed, and all of our stormwater flows down our hills, through our trees, and into Hurricane Creek and its smaller connecting streams. But everything is not always completely natural. Sometimes we build things that we need, like stores and houses and schools, and these can block the water's way while it's moving towards our streams. And when we block off the water's natural path with buildings, sometimes we get flooding. And flooding can be extremely detrimental to our buildings and our habitats for our wildlife. To help us prevent flooding, we have things like this. And you may have seen these all the time, but you don't know what they are. This is called a storm drain or a catch basin, and we use it to catch all the rainwater before it can flood the area. It connects to pipes underground that takes the water straight into our creeks and streams. Don't forget that our animals live in and use the water, so it's important that we keep it clean. Sometimes when water is moving downhill, it can pick up things that we don't necessarily want in our water. And these things can make our water dirty. And this is called pollution. There are a lot of different types of pollution that often get in our storm drains. I want to share a few of these with you all so we know how to better protect our water from them. Some of the biggest forms of pollution that we get in our stormwater are litter, oil and gas, grass and leaves, and sediment. You've probably seen litter sitting on your storm drain, and this can fall down and flow into our streams and rivers. This can make it hard for animals to swim around in the water, and a lot of the litter even carries toxins with it that can poison animals. Anytime you see litter in your storm drain or litter on the ground, make sure to stop and pick it up before it can get into our creeks and streams. Our next form of pollution is oil and gas. And oil and gas can get into our storm drains too. Have you ever seen something in the parking lot that looks like a rainbow? It looks kind of like this. This is oil, and when it rains, it can get washed into our storm drains, and those go into our creeks, remember? Gas and oil can be poisonous for animals if they swim through it, and it can destroy the feathers of birds that swim in our water. Make sure to keep your cars in good condition to prevent oil and gas spills on the roadway. Our next form of pollution might surprise you. Leaves and grass from mowing your lawn can be a form of pollution too, and they can be harmful for a few different reasons. First, sometimes they block the drain and cause flooding. Second, if grass clippings make their way into our creeks and streams, they can carry fertilizer, which is normally used to help lawns grow. But if fertilizer makes its way into our waterways, it makes algae grow. And when algae grows, it blocks the sunlight that our water plants use to grow. Make sure to always blow your grass clippings away from the street and away from your storm drains to help keep our waters healthy. Our last form of pollution is actually our biggest form of pollution that we have in our creeks and streams, and it may surprise you. The biggest form of pollution that we have is dirt and sediment. And that seems weird, right? Sediment and dirt, it's all natural, so how can it be pollution? But it can actually be extremely dangerous to us and to our wildlife. Let's explain why. Imagine you or I are playing in the water right next to a construction site. It rains and all of the sediment washes on top of us and covers us all the way up with dirt. We could suffocate and we could die. And the same thing happens to our aquatic friends like crayfish and salamanders that live in the bottom of our streams. If we get too much sediment in our water, they can suffocate and die too. And this could cause our whole food web to collapse. When we build new things or remove plants and grass, we disturb the soil and make it easier to wash away in the rain. This is called erosion. Erosion can be very, very dangerous for the critters that live in our creeks and streams. So always make sure that in your yard you never have any bare soil. You always want to cover it with mulch or straw or even plants. You can also help prevent erosion by protecting the riparian zone. This zone is made up of trees, bushes, and grass on the edge of a stream or waterway, and it helps to filter out any pollutants that might try to run off into our water. Let's recap what we learned today. We learned that stormwater is just rainwater that moves over the ground through our storm drains and into our creeks and streams. We learned about different types of pollution: litter, oil and gas, leaves and grass clippings, and sediment. And we learned how different pollutants can affect our waterways, the plants and animals that live in them, and even our own ecosystems. Finally, we learned that you can help us keep our waterways and our storm drains clean by picking up litter anytime you see it, keeping your cars in good condition to prevent oil and gas leaks, blowing grass clippings away from drains and ditches, and finally, to never leave bare dirt exposed in your yard and protecting the riparian zone. If we do all of these things, we can fill our creeks and streams with clean stormwater.
And I am the super scientist, and I see some familiar faces who've seen me before. Perfect. Good. Well, hands down, guys. Today I've got lots of different experiments we're going to do. We're going to do a bit of a show for you. Then at the end, over here, we've got a very special take-home that you're going to get to make, okay? So we're going to have lots of fun. Now, I'm going to need lots of helpers. If you want to help me, stay on your bottoms, put 2 hands up in the air, give me some big smiles. Lovely. Hands down. Now, for our first experiments, we are going to dive right into the deep end. We are going to talk about a very dangerous thing. We're going to talk about electricity. Now, who knows what electricity does? What things can electricity do? Yes?
Electrocute?
It can electrocute you. Now, is that a good thing? No! So what's a good thing electricity can do?
It can make you, like, if the power's out, you can, like, make some electricity and make a light bulb.
Okay, you can get a light bulb to work. What else does it power? Light bulbs? TVs?
Our brains.
Well, sometimes maybe, I don't know about your brains, but it powers different things. Computers, TVs, electricity gives things power. Now, one of my friends says it can do something dangerous also. It can shock. Now, I've got a special machine. This machine here is called a Tesla coil. Can everybody say Tesla coil? Tesla coil. Now, what this does is this lets me use electricity in my hands. Now, in a minute, we're going to turn the lights off. So don't be scared. First, though, let me show you what my machine does. When I plug this into the outlet, is it making any sound right now? No. Can I touch it? Yeah, nothing happens. It's a little button here. As I turn the button, can you hear that? Yeah. That is now the sound of live electricity. If I put my hand near it, what would happen? Yeah. I would get shocked, okay, and it would really hurt. Now, I'm going to turn it down so when it's not making any sound, it's not going to hurt you. And first, I need a brave helper who's feeling nice and strong and tough. Come on out, my friend. You look like a brave guy. Big round of applause for my first helper. Okay. Okay, turn around, buddy. Now we're gonna turn the lights down just a little down. Don't be scared, guys. Okay, we're gonna make it just a little darker. Oh, that's perfect. That's not too dark. All right. Now, what we have here is a light bulb. Now, this is the same sort of light bulb that we have up in the ceiling. Now, you're gonna hold this in 2 hands and do not drop. Okay, hold tight. Face everybody for me and take a couple of steps back. Okay, now. We are going to turn the Tesla coil on and move it towards the light bulb. Now hold it out straight. Don't drop. I promise it won't hurt. Now when I turn this on, how do we know the electricity's on? The noise, it starts to buzz. Now, I'm going to move this towards the light bulb. Now as I do that, what does it start to do at the bottom? Just a little bit. It starts to light up. Look again. It's lighting up a little bit. Hold it up so people at the back can see. Watch. It lights up. Now, am I touching the light bulb? No. There's a big space in between the light bulb and the Tesla coil. Now, if I put my hand in that space, what would happen?
You can get shocked.
I would get shocked, okay? Now, what we're going to do, I am going to show you the electricity. Right now, it's invisible. We can't see it. Hold it just a little higher. Move your hands down to where mine are. Now, this time it might look scary. It won't hurt, I promise, okay? Hold it in 2 hands. I promise it won't hurt. Now, when I turn this on, everybody watch the bottom of the light bulb. We get the light bulb to light up. Now, as I get closer, the electricity is attracted to the bottom of the light bulb, and you have to hold on. Are you going to hold on, or do you want someone else to help? It's fine. You got it? I promise it won't hurt, okay? Hold on to it. It won't hurt you, I promise. Watch the bottom. Hold on, I promise it won't hurt. Here we go. Watch the bottom.
It's all right, David.
There we go. Give him a round of applause for being so brave. So, you can see the electricity now traveling through the air. What color is it?
Purple.
Purple. It's pink. It's got white and yellow in. And it's jumping through the air to the bottom of the light bulb. Now, what we're going to do next. Great job, my friend. Big round of applause. I need another helper. Someone else who's feeling tough and brave. Right at the back in the grey shirt. Come on out, buddy. All right. Now, my next helper's going to come and help me. Now, this time, come on up, bud. You're going to hold on to this. Come and stand back over here. Now, what's your name? Luis. Okay, hold on to this in 2 hands. Now, do not let go, okay? What I need you to do, in a second, you're going to walk your hands up and then down, okay? Up and down. Now, don't go all the way to the top or don't go all the way to the bottom. Leave a little space. Now, everybody, let's watch the bright part of the light. When we turn the Tesla coil on, we know it's working because it starts to buzz. As we get close, the electricity's there, we can't see it. As we get closer, it now jumps through the air and we can see it. It's brightest at the bottom. Move your hands up. That's it.
Oh my God.
Keep going. And go down.
Whoa.
And go up. And go down. Now what's happening to the light?
It goes up.
It goes up and down. What makes it go up and down?
Electricity.
His hands. Now that's because I have given you superpowers. You now have the power to shock people. Now who's going to be brave and get a shock? Whoa, look at all the brave helpers. Let's go with the strong lady. Come on out, sweetheart. Big round of applause. What we're going to do, you're going to take a step over this way, and you're going to hold on in one hand. You're going to point your other hand like this with one finger. Okay, come to the side, sweetie. Now, it's pretty dark in here, so we might be able to see it. What we're going to do slowly, you're going to touch fingertips. Now, after you do that, you always use your finger, okay? After you do that, you're going to touch her elbow. You use your finger, and then, sweetie, lift your knee up, and he's going to touch you on the knee. Now, everybody, watch and listen in between their fingers. Now, hold tight and don't drop. I'm going to set it to a level 3. So it's not going to hurt, it sort of tickles. Now, don't start until I tell you guys. We're going to do it nice and slow. Now, don't start yet. We need to get the power going. Okay. Now, slowly point your finger. Listen and watch. Did you feel that? Okay. Can we see the spark? Try it again. Do your finger. Do it nice and slow. Your finger. There we go. Elbow. Lift your knee up. Perfect. And can we do your nose? Great job! Big round of applause. Excellent. Get right down, guys. Now, is anybody in here today wearing light-up shoes? Does anybody have light-up shoes on? Come and help me. I promise you won't get hurt. Come and help me. Whoa, those are cool. I like those. Come on out, Twinkle Toes. You want to help, buddy? It won't hurt. Come and help me. Anyone else would like? Come on up. Everybody with light-up shoes that wants to help, come on up. You won't get hurt. Who's wearing light-up shoes today? Okay. Now, all of my friends, stamp your feet. Show everybody your cool shoes. That's it. They all light up. All right, now what we're going to do, we are going to make your shoes light up without you having to move. What I need you guys to do is all hold hands. Can you come over here first? Hold hands. And you're going to be at the end over here. Like this, okay? Now, everybody watch their shoes. What we are going to do in a second, you're going to hold on to the light bulb. Don't let go. You will not get hurt, I promise, okay? We're going to send the electricity up the light bulb. Through your body, your body, your body, your body, through you, into all of your shoes. And all of the shoes should light up. Now, here we go. Don't let go, helpers. It does not hurt, okay? Don't let go. Give me a countdown. 3, 2, 1. Disco shoes! So you can see them all lighting up. And when we turn it off, off they go. Hold hands, don't let go. The electricity thinks they're all one giant person. When we turn it on, it flows all the way through into their shoes. Great job. Big round of applause for my great hoppers. Perfect little guy. All right, now. What we're going to do next. This next experiment is one for your librarian. Now, what are you not allowed to do in your library normally? Talk loud. Now, to help your librarian out, if you're talking loud in the library, she can now put you in this. This is Mr. Richie's electric chair. Who's going to show everybody how the electric chair works? Okay, in the white shirt, come on down. All right, now. Hold on, Scooby-Doo. Stand up now. If we look at the chair, this is made of plastic. But look, the legs are made of metal. It's all connected with metal, and there are 2 spots on the seat, okay? Now, I need you to relax and sit down right on the edge, okay? Now, if your librarian's at her desk looking around and sees you talking too loud, instead of having to tell you to be quiet, she's just going to be able to touch this down and see what happens. So face everybody, try and relax. Here we go. 3, 2. No, oh, move over then. Let's see if we can get it just on the right spot. Oh! Big round of applause. Anybody else? kids aren't eating their vegetables at dinner, you can use this. So here we go. Face everybody. Try to stay calm. And sit down. And... Ah! Great job. Thank you. Now, for this next experiment, I need a little lady. You will not get hurt, I promise. I need a little lady. Okay. Now, my friend here, turn around, has got a beautiful smile. Show everybody. Okay, now, you're going to be Mother Nature, and you're going to be mad and angry, so show me an angry face. That's a happy face. She's okay. All right, Princess, what we're going to do, this is the Earth. Who lives on Earth? All right, now, we're going to turn the lights down. Now, we've got some nasty weather the last couple of days, so stand back here, Mother Nature. Hold on to this. This is a thundercloud. Now, when we have a thundercloud, we get rain and we get lightning.
Oh my God!
You can see the lightning strike. Now, if the lightning hits the wrong spot, it can do a lot of damage. Now, stand back, sweetheart, just for a second. Here, this piece of paper is going to be a tree. Now, if you're ever outside in a thunderstorm, one of the worst places you can stand is under a tree. Now, hold on to this, Mother Nature. Don't let go. We're going to let the lightning hit the wrong spot. You're okay? Here we go. 1 second. Now, if that was a tree, that tree would come crashing down on your head, and would that feel good? No. Okay. That would be really bad, right? Big round of applause for Mother Nature! All right, friends, now we're going to put the electricity away. If you came up to the front and have helped me already, please don't put your hand up. Let some other people come and be my helpers.
I have
For my next experiment, I need somebody who's not afraid to get wet. Let me get somebody in the America shirt. Come on down. Here we go. All right, big round of applause. All right, now I need you to come and stand over here. Turn around and face everybody. Now, don't move, okay? In this container, what do we have? Water. Put your hand in there. Take your hand out. How does it feel? Wet or dry? Wet. It's wet. Just so you know, I'm not cheating. This is proper water. It's a proper liquid, okay? Now, I'm going to pour the liquid into one of my 3 cups. Here I have 3 blue cups. Now, let's pour the liquid into this one. So watch carefully. Make sure I'm not cheating. We pour the liquid in. All right, let's see. Now, which cup did the water go in? Did it go in this one? No. This one? No. This one? Yes. Now watch, because I'm going to start to move the cups. And tell me when to stop. Stop. Okay. Is the water in this one? No. This one? No. This one? Yes. You guys are too good for Mr. Ritchie. All right, I'm going to go really quick this time. Now remember, it's in this cup, right? No. Watch where you think it is as we move them around again. Tell me when to stop. Stop. Okay. Is the water in this one? No. Let's have a look. Give me a countdown. 3, 2, 1. Oh, not in the first one. Is it in this one? No. Let's have a look. Give me a countdown. 3, 2, 1. Not in that one. That means it's in that one. All right, let's have a look. I'm going to stand back so I don't get wet. 3, 2, 1. this one, it's not under this one, and it's not in here. Now, what if you make water really cold? What does it turn into? Ice. Now, I didn't make it really cold and turn it into ice. What if you boil it and you make it really hot? It turns into gas or steam, okay? Now, I didn't do that either. I did cheat a little bit. Before you guys came in, I put a special powder in. Now, hold your hands like this. We're going to tap the side of the cup. 1, 2, 3. So we give it a few taps and we turn it upside down. Now.
What?
Poke it with your thumbs. Is it hard or soft?
Soft.
Let Mr. Ritchie feel. Rub your hands together. Do they feel wet or dry? They're dry now. So what we're going to do, we turn the water from a liquid to a dry gel. Could you drink that now? No! Now what we're going to do, we're going to walk around and let you feel this. So could you walk around this half and let people poke it? Do not put it near your mouth, okay? Get ready to poke it. Does it feel like a liquid? That's it, you ready to go? Poke, 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 poke.
Oh, it feels weird. Oh, it does. I got one. You feel like that? I got one. Skip. Hey, you can. That's your bag. Hey. Excuse me. American shirt. American shirt. Yeah, he got shot. He's just throwing it right now too. Matthew, you go. I wish if he was holding it.
All right, guys, now, just so you know what you've been touching. This started out as a white powder, and it started out as baby diaper powder. This is at the bottom of a baby's diaper. It's called polyacrylamide. It's also used by astronauts in space, okay? It turns a liquid into a soft solid. Now, we're going to move on, and we're going to talk about one of my favorite things in science. We're going to be talking next about a special thing. Who knows what this is?
Dry ice.
This is dry ice. Now, dry ice is one of the coldest things in the whole world. It's 109 below zero. It's so cold that if you touch it with your finger, it will burn your finger. So you can never touch it. It's so cold, it feels hot. So you can never touch this unless you're wearing a glove. Now my hand's getting really cold in the glove, but luckily it's not getting burnt, okay? Now if you move it, what can you see? Smoke. Steam, smoke. Dry ice is called dry ice because it's not got any liquid, okay? It's never a liquid, it's a gas. A frozen gas. Now, what we can do is lots of fun things with it because it's cold and because it's a gas. Now, first, I need 2 helpers who've not been to the front yet. Let's get in the blue at the back and in the white. Yep, come on out. All right, now I'm going to give you a quarter and one to you. I'm going to give one to you, buddy. Stay where you are. I'm going to give one over this side to you, sweetheart. Stay where you are. And in the middle, in the white shirt. Okay, now, if I give you a coin, put it in your hands like this. Everybody else, put your hands together like this. Now, let's create heat by making some friction. So slowly rub. You don't really feel much. Let's get quicker. And let's get quicker. And let's go full speed. Rub, 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 rub. And touch your cheeks. How do your hands feel? Hot, right? Now we want to rub, rub, rub to make this coin hot. So keep rubbing. Rub, rub, rub. Now we want the coin to be hot enough to start to dance. Now to make it dance, We hold it at the top. We're going to push it down. 1, 2, 3. Can you see it starts to move all on its own? So it starts to shake back and forth. Now, did we hear anything when we first pushed it in? Yeah, we heard a sizzle. Okay, now hold the top of yours. Make sure we don't touch the ice. Hold on to it. Here we go. 1, 2, 3. Let go. Perfect. Stay at the front. Push yours in. 1, 2, 3. Lovely. Okay, stay at the front. Who else has got one? All right, you guys, just turn around and have a look. So turn around and have a look. 1, 2, 3. Let go. That was a hot one. That was excellent. So you can see it start to shake. We've got one in the middle. I know we've got one in the middle for you guys. You can see this one, don't worry. Push yours in. Don't touch the ice. Be careful. 1, 2, 3. Let go. Perfect. And then one over this side. Watch out. Push yours in. 1, 2, 3. All right then, friends. Now, as I was walking around, the coin started to shake. What happened to these first ones we put on? Well, what makes you say they froze? What color have they turned? They turned white. Now, the dry ice is so cold that if you put a quarter on it, it will freeze mega quick. Hold your hand out like this. You're going to pass these around. The ice is too cold to feel, but you can feel the quarter. These are really cold, but they, get ready to pass them quick. Quick, pass. Quick, pass it around. Pass it around. Okay, guys, let Mr. Richie get his money back. Thank you. Anybody else? Lovely. Okay. Now, next, guys, we're going to do a listening experiment. Dry ice, we said, is really cold. Compared to the ice, thank you so much. Compared to the ice, this pan lid is hot. Now, when the ice hits the metal,
it turns up. Makes vibrate.
You get one sound. Two sounds, and then this one's my favorite. Is that you? Whoa! So we got one here, and then in the middle's that stinker. Now, when the ice hits the metal vibrates. Show me vibration. Some vibrations are big. Some are teeny tiny. If the vibrations are big, stretch your arms out wide. It's so awesome. Everybody make a loud sound. If the vibrations are small and close, put your hands really close. It's high! Now, what I need you to do is take a big breath and you're going to follow my hands, okay? So, ready? Breathe in. Ah, stinker. That one's rude. Now, next, we're going to make a potion. If you don't want the potion, you don't have to have it. Just put your hands on your head. If you do want it, stay on your bottoms and I will try to get you. I need 2 helpers who have not helped me yet. In the,
I have a help.
yeah, in the black shirt. Who's that? Is that Buzz?
No.
Lightning McQueen. All right, now, come and hold on to this. 2 hands. Now, sweetheart, you're going to hold on to this with 1 hand. There we go. All right, now turn around and show everybody. Now, what we're going to do, we're going to make a potion using our dry ice. So with my hammer, I'm going to break it up into some little pieces. And we're going to put those little pieces in the container. So let me just see it for 1 second. Now, hold this in 2 hands. Do not drop it. Will not hurt you, okay? I promise. So be brave. Face everybody so they can see. Now be really brave. Hold it in 2 hands. It won't hurt you. Turn around. I'll hold it with you. Turn around and face everybody. Okay. Now hold tight. It doesn't hurt. Can you hold it for me? Yeah. Hold tight. All right. Now. That's perfect. Now just take a step back. Add a squirt of super science liquid. Now don't be scared. A little bit more than that. There we go. Give it a squirt. Perfect. We add a little bit more. And now put that back on the table. This is now a super science Don't move, guys. I'll come and get y'all. A little bit. We're going to do an explosion next, okay? Okay, stand up here. Turn around and face everybody. Now, this first one is not one you should try on your own, okay? Well, this first one we're going to use some dry ice again. So we break it into a little piece using my hammer. And we're going to put that into a film canister, and you're going to hold this up above your head. Hold on tight, okay? Point it up. Now, we are going to add a little bit of water to get it smoking. Can you see it start to smoke?
Yeah.
All right, now hold it down here. You're pretty tall. Okay, now just away from your head. That's it. Now, we are going to add a lid. Right now, all that gas is coming out, all the smoke's coming out. when we put the lid on, the smoke is trapped. It starts to push. Now hold on tight, because any second, something should. In a second, it should.
Explode!
Five, 4, 3, 2, 1. Sit back down. Anyone else want to go? Last one. Hold on. It fills up. The smoke pushes until there's no space left. And all right, guys. Now, if you saw there, that one is a little dangerous. Sometimes the ice will pop out, and you might accidentally touch it. So that's not one you should try on your own. This next one is one you can try with your family, okay? All you need is a film canister. You can get these free at Walgreens. Now, where's my lid at?
It's back there.
Oh, I got this one now. You need to make sure you've got a clear lid, okay? They'll give them you free at Walgreens. You need one of these, and you need an Alka-Seltzer. And this is going to turn the bottle into a rocket. It's best to do it outside because this will go above a house, all right? Come on out. Now, what you're going to do, you're going to break the Alka-Seltzer in half. So snap that in half. We're going to put a little bit of water in the container. So we fill it up about a quarter of the way. Now, you're going to drop both pieces in. I'm going to snap the lid on. We're going to turn it upside down, and it's going to blow up. Here we go. We need to back away after we put it in. Get ready to drop them in at the same time. Both at the same time. Drop it in. Back away. All right, here we go. Now this one is safer because you can touch the Alka-Seltzer afterwards, and the bubbles are what caused the explosion. All right, thank you so much. Sit back down. Now, friends, we've got a special treat for y'all. Here in a second, we're going to move on to do our making portion of the show where you get a take-home. Now, before that, we've got a couple of announcements. I am Mr. Rich from Super Science. We have a soccer science camp next week down the road in Murfreesboro. I've got some flyers around. It's loads of fun. We build rockets and race cars, catapults, different things, and then we do soccer in the morning. So it's loads of fun. If you'd like to come, we do still have spaces available. I also do birthday parties where we can come to your house and we can do our fun stuff at your house. Now, can we do the announcements next?
I'm Julie Scardina here at SeaWorld San Diego. Are you ready to get up close and personal glimpses into incredible rescue attempts? A behind-the-scenes look at phenomenal rehabilitation efforts and witness spectacular animal releases? Well, you've come to the right place because SeaWorld and Busch Gardens have been leading the way in animal rescue for a very long time. You know, the Anheuser-Busch Adventure Parks have been committed to wildlife preservation for over 40 years. No other organization has rescued, rehabilitated, and released more animals. SeaWorld and Busch Gardens have rescued 11,000 animals since 1965. And SeaWorld, in the past 5 years alone, has helped more than 3,000 animals, including seals, sea lions, dolphins, whales, sea turtles, and even seabirds. 24/7, 365 days a year, SeaWorld's animal rescue and rehabilitation teams respond to calls for animals in distress, then to be assisted by an expert group of dedicated veterinarians, animal care specialists, and marine biologists. But the Anheuser-Busch commitment reaches far beyond the rescue of a single animal. From Antarctica to the Arctic, SeaWorld and Busch Gardens are working to save some of the planet's most endangered species and habitats. I'll be back shortly to give you an even closer look at which specific species of animals are being helped. In the meantime, let me introduce you to my colleague, Chuck Carreau, as he takes you on some amazing animal rescues. Chuck?
Thanks, Julie. You know, SeaWorld and Busch Gardens have performed some truly amazing rescues. But did you ever stop to wonder why these rescues have to take place at all? Well, sometimes stuff just happens. And of course, you can't control a natural disaster like an earthquake or a hurricane. Other times, events are triggered by humans. In June of 2000, off the coast of Cape Town, South Africa, a sunken freighter caused an oil slick that resulted in the worst bird disaster in history. A worldwide call to action went out, and SeaWorld, along with many others, immediately answered. Just like this little guy here is getting a good chance at surviving, an entire colony of South African penguins and their chicks got a second chance, thanks to a lot of caring hands. It comes as a surprise to many people to hear that South Africa is home to penguins. These seabirds are a permanent fixture along the southern coast. However, June 23, 2000 marked a fateful day for the penguins when the bulk carrier ship, the Treasure, sank off the coast of Cape Town. About 400 tons of oil spilled from the ship and began washing onto Robben Island, home to nearly 20,000 African penguins. Soon after, shifting weather patterns pushed oil towards Dasson Island, where 56,000 African penguin adults and chicks live. With worldwide numbers totaling only 150,000 birds, this spill threatened almost half of the entire African penguin population. Jay Holcomb, Director of International Bird Rescue and Research Center and on-site manager of the International Fund for Animal Welfare, intimately knows what it takes to pull off a rescue attempt of this magnitude. He discusses what zoological parks and staff bring to a rescue such as this.
To manage this many birds takes a lot of supervision. The volunteers are wonderful. They come in hordes. We have 700, 800, 900 a day to come in, but they all have to be supervised. So what we've done is brought in people from zoos, aquariums, wildlife rehabilitation facilities from around the world that we put under our management system that we've created, and they help us manage the volunteers.
These guys just... With a rescue that totaled over 23,000 oiled birds, people from around the world pulled together to save the penguins. The South African military and thousands of volunteers with varied backgrounds, education, and experience offered whatever time and service could be utilized. With numbers totaling over 40,000 volunteers, the Red Cross set up its own rescue center within a rescue center just to tend to the humans. Once the penguins arrived at the Sandcob Salt River facility, people were propelled into action. Dry pools were set up to keep the frightened penguins contained. As quickly as possible, the penguins were fed and hydrated. SeaWorld aviculturist Alex Ware headed up this part of the rescue process.
Right now we're doing a mixture of force feeding, offered hand feeding for the ones that are starting to get an idea of how to do it, and my team is currently going through and tube feeding some electrolytes to keep the birds going because dehydration is becoming a big issue. Some of these people are they're just whatever it takes, you know. I mean, they're shoveling dirt, they're scrubbing buckets. You know, everyone wants to help out in any way possible, and after a few days, you know, you try to find something that's a little less physical, because these little penguins, they're extremely strong animals, and even skilled handlers like myself are sporting wounds and scratches and beauty marks, and I'm a careful penguin handler, and it's happening to me, so, but they keep coming back, and it's amazing.
As quickly as possible after the penguins arrived, they were sent for a washing. Unfortunately, this is a very slow and tedious process, requiring a minimum of 2 people for each bird and almost an hour of time. Then, the birds were rinsed and dried, but not yet ready to be returned to the wild for 2 primary reasons. It takes 4 or 5 days for the penguins to regain their natural oils after washing, and the spill was still a danger zone. So, the Sandcob facility became a holding facility as well, and the penguins required special care. They needed crushed shell to keep their feet clean, food, and of course, water. What a difference in energy once these birds could swim. And what an amazing transformation to turn an empty railroad warehouse into a penguin rehab center of this magnitude.
When the spill first happened, they must have known that this was going to entotal so many penguins, and they knew what kind of space requirements they were going to have, because I walked in, I was like, why do they have that huge factory for these birds? And now we're just filling it up. Every day we're needing another room, and to be able to keep it all central right here in one area rather than satellite rehab stations, everyone doing their own thing, it's a good thing for the animals, and it makes it very easy to coordinate the volunteers.
Another unfortunate detail in this oil spill was the timing. It occurred in the middle of chick rearing season, and both mom and dad take part in raising their young. Parents were swimming through the slick in search of food, returning to the islands oiled, which would eventually make them unable to swim. They were also regurgitating oil to their chicks. Until SeaWorld aviculturist Lauren Dubois and Baltimore Zoo colleague Steve Sorrow arrived in South Africa, it was too much time and effort to focus on saving the younger birds.
Basically what we're trying to do here is most of these birds have just come off the nest, and we're trying to get them to eat. What we're doing is once a day we're coming in and we're doing a force feeding, which is basically picking the bird up, making sure he gets 2 to 3 fish, and then in the afternoon we'll come in and we'll sit in the pens as the birds are getting used to us and try and offer them fish and give them sort of a hand feeding or free feeding. Once they eat on their own and we know that they have a good weight, then we'll go ahead and look at a time when we can release them.
Over 500 chicks were eventually returned to Dassin and Robben Islands, prepared to grow into vital adult penguins, helping to preserve their species. Upon her return, Lauren put it all into perspective.
My experience in South Africa pretty much changed the way that I take care of animals and anytime I see animals. It was a very stressful situation coming into seeing many animals that had been injured by a man-made disaster, and being able to help take care of those animals and see those animals released and be healthy animals was a tremendous feeling of satisfaction to know that something that I did helped these animals to go back into the wild.
Lauren is an integral part of SeaWorld's new Oiled Wildlife Care Center, which opened its doors in July 2000.
The Oiled Wildlife Care Center is set up to do everything for an animal during an oil spill, and that includes the intake procedures, evaluating the animal, washing the animal, whether it's a mammal or a bird, and also care for the animals and support before the animal would be able to be released.
23,000 oiled birds made the South African oil spill the worst bird disaster in history. But with the dedication and skillful help of so many people from around the world, the worst bird disaster in history ended up to be the most successful rescue attempt to date. Of course, a rescue is always about the animals, but somewhere along the line, it can't help but be about the people as well.
California sea lions like these are abundant off the U.S. West Coast. That's not the case for another pinniped, the very endangered Hawaiian monk seal. Recently, an unusual form of blindness swept through Hawaiian monk seal colonies, putting their already dwindling population in even further jeopardy. SeaWorld San Antonio helped rescue several of these blind seals in an attempt to not only save these few, but learn more about this pinniped in hopes of understanding ways to protect their entire species in the future. It's an amazing thing.
The Florida manatee has a legendary history dating way back before Christopher Columbus. Now, often the source of mistaken identity, this gentle giant has been called everything from a monster to a goddess. Well, whatever label you choose, there's one manatee that can be called just plain lucky. Now, don't mistake him for a reindeer or for a meteor. This is the story of Comet, the Florida manatee that ventured back to Florida by way of Ohio. Ohio.
Slow and gentle, manatees capture the hearts of all that see them. However, seeing them can be somewhat difficult as they come to the surface to breathe. And it's their slowness that may actually increase their chances of being injured by boat collisions, one of several factors that threaten this endangered species today. Manatees and their relatives are found in oceans, bays, and rivers all over the world, although we're looking specifically at the West Indian manatee, which is found throughout the Caribbean and Florida. Manatees are mammals that are completely vegetarian, eating primarily seagrass. But don't let that fool you. They can weigh up to 3,000 pounds. Unless they are mother and calf, manatees typically live a solitary life, although in winter they may migrate with groups in search of warmer waters. The story of Comet starts in January of 1998 in Fernandina Beach, Florida, where he was found with his mother, who had been hit by a boat. SeaWorld's animal rescue team responded to the distress call to find a very injured mother and her year-and-a-half-old calf who was still nursing. The mother, named Mercury, sustained many large wounds on her right side, and SeaWorld vets discovered that she had several broken ribs that were causing a severe infection. Working with veterinarians from the University of Florida, the infected, fractured ribs were removed. Although Mercury began to eat following surgery, her wounds were too severe and she succumbed to them shortly after. The focus then shifted to doing everything possible to save her nursing baby, now known as Comet. Comet received around-the-clock attention and thrived under SeaWorld's care. Fortunately, he was old enough to begin eating on his own, and when he became strong enough, was introduced to other manatees in the rehabilitation area. Then, in June of 1999, Comet was doing well enough that he was one of several manatees transported to the Columbus Zoo's new manatee habitat. How about that? Manatees in Ohio. Doug Wormeltz, Assistant Director of Living Collections at the Columbus Zoo, explains why this is important.
It's important for people in Columbus, in central Ohio, in the Midwest to know about manatees. We use Florida as a vacation spot, and our lifestyles directly impact the survival of these animals, and we need to learn to be responsible, make a choice, and learn how to live with wildlife.
After more than a year of helping to educate guests in Ohio, it was time for Comet to come home. In a collaborative effort between SeaWorld, the Columbus Zoo, and government agencies, a transport and release strategy was designed and executed. Upon his return to SeaWorld Orlando, Comet was prepared for release into the St. Johns River, along with another rescued manatee named Corey.
Comet was released with Corey, a younger animal, today, so hopefully they'll stay together for a while. They're going to encounter the wild manatees that are in the spring, so Comet will probably learn where the food sources are and learn to move back and forth between the river and the spring, but eventually he'll probably go on his own.
SeaWorld Orlando is one of several manatee rescue and rehabilitation facilities in the state of Florida. Equipped with trucks, gear, and staff, they are ready to roll immediately to the scene of a manatee emergency and are set up to treat the animals on site and upon their return to the park. Manatees, the last generation, serves as a home to animals unable to be released and, like the Columbus Zoo exhibit, helps educate visitors about the plight of the manatees.
Every 10 to 15 minutes they go up for air. Manatees endangered because of all the boat accidents and red tide and their curiosity.
It may seem like a lot to go through to save one animal, but today a manatee named Comet swims free, slow and gentle, and brings the overall numbers of this endangered species up by 1. SeaWorld thinks that alone is worth it.
There's almost no problem that can't be solved with good old-fashioned ingenuity. Just ask SeaWorld of Florida. When an injured manatee needed help floating, a specially designed wetsuit came to the rescue. And when a baby manatee needed to nurse, but the mother was unable, SeaWorld developed a manatee milk formula to nourish the calf. It's an amazing thing.
Attaboy. You know, some healthy marine mammals like sea lions, seals, and walruses naturally haul out onto land at times. Now, they might do this to mate, bear their young, or simply to rest. But, you know, sometimes animals haul out because they're ill or injured. In this case, an animal is considered stranded. That means it's helpless and unable to survive under the present conditions. Animals become stranded, well, for many reasons, ranging from disease, toxins, injuries, parasites, entanglement, oil spills, and believe it or not, weather events such as El Nino.
Although the cause of El Nino remains a mystery, it's an ocean event that has far-reaching effects. It might increase rainfall across the southern U.S. while causing horrible flooding in Peru and severe drought in the West Pacific, which might cause devastating brush fires in Australia. Meaning the little boy, or Christ child in Spanish, El Nino got its name since it often arrives around Christmas. During an El Nino, there's a change in normal trade wind strength in the central and western Pacific, which impacts surface water temperatures off the coast of South America. As water temperatures rise, the warmer waters aren't as nutrient-rich as the normal colder waters, and this starts an adverse reaction that moves all the way up the food chain. A lack of nutrients causes some vital plants and animals to die, while others can't survive and thrive in warmer waters, forcing animals that depend on them for their own survival to starve. It might also force animals, fish, and birds to migrate to other areas in an attempt to survive. This often results in animals stranding or ending up in areas not common to their species. And this results in an increase in rescues during an El Nino. SeaWorld San Diego's Assistant Curator of Animals, Keith Yip, explains.
During the El Nino event, we rescued over 350 animals. So far this year, for instance, we've only rescued 35 animals. I'd say the average is about 75 to 80 animals every year, and sometimes around 100. But 350 is an excessive number of animals.
What if you find an animal that appears stranded or abandoned? Observation is the first step. Often, in the case of a youngster, the mother may be off hunting, so unless the animal is in distress, you should simply watch it for a period of time. If the animal does require intervention, contact your local wildlife rescue and rehab agency. Often, humans think they're doing the right thing by intervening. However, these decisions are best left up to the experts that are trained and equipped to deal with these crisis situations. Many things can impact animals and their welfare, including weather. Sometimes nature needs to take its course. Other times, a helping hand, or lots of helping hands working together, is just what the doctor ordered.
SeaWorld California is the first and only zoological park in the world to successfully breed emperor penguins outside of Antarctica. Researchers at Hub SeaWorld Research Institute in California work best in noisy conditions. They studied penguin vocalizations in both Antarctica and at SeaWorld to determine, of all things, gender. Prior to the studies, only the penguins knew who the boys and girls were. Now, we do too. It's an amazing thing.
Sometimes things happen in nature for reasons no one understands, and human intervention becomes a crucial factor in the survival of an animal. This is the story of Callie, the giraffe, that with the help of Busch Gardens caretakers, veterinarians, and designers, stood just a little bit taller and a whole lot steadier on her feet.
There's no question that Busch Gardens Tampa is a fun and exciting theme park. But did you know that what looks like a cool place to see animals is serving a major worldwide function? Several animals housed at Busch Gardens and SeaWorld are actually part of breeding programs, which help ensure the overall survival of threatened and endangered species. Every day, guests at the park can get a glimpse of the newest additions to the Busch Gardens family by stopping by the nursery. Not all animals in the nursery are endangered or threatened. Sometimes, for various reasons found in nature, the mother is unable or unwilling to care for her offspring, or the baby may be sick or need special care. This was the case with Callie the giraffe. Callie, a reticulated giraffe, was born prematurely at Busch Gardens Tampa. Normally, giraffes can get up and walk on their own within minutes after birth. Callie, however, was just too weak to support herself. Weighing just 75 pounds at birth, she needed round-the-clock nursing care for the first 5 days. She was then able to stand up, but her forelegs needed support. Busch Gardens veterinarian Dr. Noah Abumadi determined that Callie's legs could be supported with braces, which would allow her to walk and strengthen her weak legs and joints. Shriners Hospital for Crippled Children was called to assist in the evaluation and design of the braces. A little extra support was just what Callie needed to boost her confidence. With her newfound stability, she was able to be walked and exercised, growing more sturdy as each day passed. Eventually, she was strong enough to walk and run on her own, where she joined the other Busch Gardens giraffes on the open veldt. Not only are breeding programs important as a way of increasing population numbers of a species, but also genetic diversity. SeaWorld aviculturist Rob Yorty explains.
When you're actually thinking about possibly releasing an animal, you don't want any latent genetic problems in their traits that could come out when the animal's actually released out in the wild and reproduces. So by this way of having a very large number of animals, we can keep track of all their genetics and make sure we don't have any weaker individuals, so to speak, that may be part of a reintroduction program.
Zoological parks provide fun and entertainment, no doubt. But look below the surface and you'll discover dedicated people devoted to conserving and preserving animal welfare, diversity, and population. Global concern on a local level.
Like Magellanic penguins, the Lear's macaw is also from South America. One difference is the Lear's macaw is in extreme peril as more and more of its habitat is being harmed. Busch Gardens supports efforts to protect this beautiful bird and its food source and has sent researchers to study its behavioral patterns and monitor nest sites in order to gain insight into how the Lear's macaw can survive. In addition, Busch Gardens is the only zoological park in the world to have successfully bred the Lear's macaw. It's an amazing thing.
Rescuing a marine mammal like a seal or a sea lion is hard work. But can you imagine what it's like rescuing an animal the size of a gray whale? Well, size is only one thing that makes this next story the most amazing animal rescue of all.
It was a fateful day in January 1997 when an abandoned gray whale beached herself near Marina del Rey, California. The whale was only a few days old when she was rescued and brought to SeaWorld San Diego. Only 14 feet long and 1,500 pounds, the little whale was found to be dehydrated and almost comatose. She was so weak that animal care team members had to hold her upright in the water and swim her around the medical pool. The outlook was not good. Dr. Jim McBain gave the grim findings.
Well, the animal is in pretty weak condition. It's dehydrated, it's very short on energy resources, energy supplies, it's very thin. The prognosis for full recovery is no better than poor at this point.
But with the dedication of the SeaWorld staff giving round-the-clock care, the little whale known as JJ overcame the odds. JJ was put on a specially formulated diet made up of a mixture of heavy cream, minced fish, and vitamins. She was hand-fed the formula at first and gained weight at an astounding rate. Eventually, JJ was introduced to solid food and was eating on her own. JJ thrived at SeaWorld, and as she grew, so did her pool. She became the center of attention as people from around the world followed her progress and visited her in San Diego. It gave so many the opportunity to get their first real-life look at a gray whale. There's much yet to be learned about gray whales, their patterns and habits. JJ gave us the opportunity to learn a tremendous amount about gray whales, their needs, and requirements. As JJ grew, it was discovered that her vocalizations didn't show the wide range of sounds gray whales normally make. It's known that these vocalizations play a very important communication and navigation role in the wild. With the help of audio technology, researchers piped different whale vocalizations into her pool as she was feeding. They hoped that when JJ was released back into the sea, she would recognize these calls and sounds and follow them to other gray whales. After 13 months of constant care, literally tons of food, and lots of love, it was time for JJ to be released. She was well over a year old, weighed 17,000 pounds, and measured almost 31 feet in length. It was no small task to design the equipment, gear, and strategy to transport JJ to the sea. On March 31st, 1998, in a bittersweet mixture of laughter and tears, JJ was released. After only a few days, she scraped off her tracking devices, so there was no way to follow her. She was released as the gray whales were making their way north to the colder Arctic waters. Hopefully, after learning their sounds, being taught to eat, and thriving so well at the park, she connected with the other whales and has been making the annual migration with them ever since. The story of JJ is truly one of the most incredible rescue and rehab stories in which SeaWorld and the world has been involved. The story of a little whale that taught us more than we could imagine, that taught us to believe in miracles. The story of a little whale that will leave her footprint on our hearts forever.
We've seen that things can happen at the hands of humans that may affect wildlife, like boating accidents with manatees and oil spills. We also know that some things are beyond our control, like weather events such as El Nino, and we understand that sometimes, well, nature just has a mind of her own, as seen with the stranding of animals like sea lions or whales. But even though we may not always be a part of the problem, we can be a part of the solution. On behalf of Anheuser-Busch Adventure Parks, this is Chuck Carreau thanking you for joining me in some of the world's most amazing animal rescues.
I hope you enjoyed your journey. And rest assured, as long as there are animals that need help, SeaWorld and Busch Gardens are committed to playing their part in rescue, rehabilitation, and release.
I'm Jennifer Pulley. Welcome to NASA 360. Okay, right off the top, I got a quick question for you. Where does NASA launch most of its space missions? Well, for those of you that don't know, let me give you a hint. If I said launch at the Cape, would you know it then? Yep, it's Cape Canaveral, the Kennedy Space Center. The Kennedy Space Center has been the launching point for virtually every NASA mission since, well, the beginning of NASA. This place is amazing, and today you're in for a special treat because NASA 360 is going behind the scenes to take a closer look at some of the amazing facilities here at Kennedy. And we'll also meet some of the people down here on the Space Coast of Florida who make those launches possible. Here's Johnny Alonso to get the show rolling.
Hey, how's it going? I'm Johnny Alonso. Today I'm at one of the most recognizable places in the world, the Kennedy Space Center in Florida. This is where all the most important American missions have been launched. Dig it, missions like Mercury, Gemini, Apollo, Skylab, and all the shuttle flights, and not to mention hundreds of other important scientific flights too. This will also be the place where NASA's new Ares rocket will blast off into space when we go back to the moon. So this is the place to be if you want to know how NASA gets these huge rockets into space.
Main engine ignition. 3, 2, 1.
So what does it take to get a vehicle in space? Well, it's not very easy. Thousands of people must perform extraordinary jobs every day just to get a vehicle ready for launch. And I'm not talking about all the planning and engineering it takes to build a spacecraft. No, I'm talking about just getting it ready to fly, putting it in launch position and blasting off into space. But before we start our tour, let's take a few minutes and talk about some of the important historical events that have happened here at Kennedy.
It wasn't until near the end of World War II when the U.S. really started getting interested in rocket flight. The main reason was because the Germans were using a rocket called the V-2 as a weapon against us. Even though this was a terrible weapon, American planners saw the potential this rocket could have militarily, and as a forerunner to large rockets that could help us explore space. So after the war, the military brought about 100 captured V-2 rockets back to the States and began testing them in New Mexico. It wasn't long before researchers realized that they needed a place to test longer-range rockets. So in 1949, President Harry Truman established the Joint Long Range Proving Ground at Cape Canaveral. The Cape was the perfect place for this type of testing because its location was so remote that nearby communities would not be in danger, and of course the weather permitted year-round testing. Okay, fast forward a few years. It's now 1957, and the Navy was testing the Vanguard rocket to send the first satellite in space. They had sent up 2 of these rockets on suborbital test flights, but we're all in for a big shock on October 4, 1957, when the Russians beat us to the punch, launching Sputnik, the first man-made satellite into space. The race for space was now on, and soon the name Cape Canaveral would be one of the most well-known places on Earth.
Soon after Sputnik was launched, NASA selected the first astronauts to participate in our manned spaceflight efforts, Project Mercury. And one of the main goals was to learn as much as possible about space to help us to get ready to go to the moon.
On May 5, 1961, Alan Shepard became the first American in space with the launch of the first Mercury flight called Freedom 7. Although his flight was suborbital and only took about 15 minutes, the U.S. had done it. We had put an American into space for the first time. In that same year, President Kennedy told the world that the U.S. would be striving to put humans on the moon and bring them back safely by the end of the 1960s. So with this new deadline, training and flights began getting fast and furious. After the Mercury missions were complete, Project Gemini was launched. Astronauts gained valuable information on docking in space while also performing the first American spacewalk. But with the last Gemini flight in 1966, all eyes turned to Apollo, and the moon was our next target.
It's amazing, isn't it? In just under 10 years, we went from barely understanding how to get humans off this Earth to preparing to send them to the moon.
So on July 20th, 1969, the nation's goal of putting humans on the moon was realized when Neil Armstrong and Buzz Aldrin landed at the Sea of Tranquility on the moon.
Tranquility Base here. The Eagle has landed.
This flight was followed with 6 other Apollo flights, with Apollo 17 becoming the last flight to the moon. NASA quickly closed the book on the moon missions, focusing their talents and technology on a new craft called the Space Shuttle.
Now, many of you watching this have never known a time when humans weren't flying in space. A lot of us take that for granted. But let me tell you something, it's not easy to prepare everything you gotta do to get up to space. All right, so are you ready to go on a tour? Let's roll and check out some of the facilities here at Kennedy and meet some of the hardworking people that are making these spacecraft fly.
The VAB is where the space shuttle gets assembled for spaceflight. This is how it works. First, the solid rocket boosters are mated together and attached to the giant external fuel tank. Then the orbiter gets towed and raised to a vertical position with overhead cranes. It's attached to the other components and is ready to go. Well, almost ready to go.
So how to get the orbiter out of this building and onto the launch pad? Well, with one of the baddest moving trucks you've ever seen. Around here, they just call it the crawler. Tell me about the crawler.
Well, Johnny, the crawler was built about 1965, and it was basically the main transport to take the Apollo vehicle from the vehicle assembly building out to the pad.
This thing is huge.
It's 130 feet long, about 115 feet wide.
And what's max weight on this thing?
Well, let's see, the crawler, it's about 6.5 million pounds. Pretty heavy. So it stays on the ground, no problem, you know? But the crawler carries, right now it's carrying about 13 million pounds.
13 million pounds.
Yeah, so you got a total weight of crawler and vehicle of about 18 million some pounds.
Oh my goodness.
Rolling down the road.
I'm going to assume this thing doesn't go very fast.
It's not real super fast. We like to keep it probably around a mile an hour. Now its design speed when it was first designed was almost a speed of 2. But actually it is fast when you're on the crawler. I mean, because of the mass that it's moving.
So you fill a tank up. I'm just going to ask you, if you fill up the tank, I mean, you know, what can you get per gallon?
Well, it's about 38 feet per gallon.
38 feet per gallon?
Oh, yeah. Yeah, and we actually have 2 tanks on the crawler. Each are 2,500 gallons apiece.
Oh, my goodness.
Yeah, so it'll last a couple of operations.
Tell me, what does the crawler do?
Well, the crawler, the basic task of the crawler is to pick up the mobile launch platform. The mobile launch platform, of course, has the vehicle stack on it.
Sure.
And it moves it from the assembly building and it moves it out to the pad. Okay. And then sets it down and then moves back away from it. And then once the vehicle launches, it goes and picks up that mobile launch platform and brings it back to the vehicle assembly building for another stack.
Is there only one crawler?
No, there's actually 2.
Are there?
Yeah, NASA had 2 of them built back for the Apollo program.
All right, so we know what kind of mileage this huge thing gets. How's it powered?
Well, you know, funny she'd ask that. Why don't we just go up here and we'll check it out?
Let's go.
Yeah, walk back into history.
Oh, look at this.
These engines here, those are the same engines that have been on here since '65.
Since 1965.
This is what powers the crawler here. There's actually 2 of these. There's one here, one on the other side.
Okay.
And each one of these powers 2 1,000 kilowatt DC generators.
Really?
Kind of works like a diesel electric locomotive.
Sure. Let me ask you, so how do you move this thing? How do you drive it?
Well, come on, I'll show you.
Sure.
We'll walk right up here. Okay, Johnny, come on. Let's come in this cab right here.
Okay. Oh, cool.
This is the operator's cab.
Wait a minute, wait. That's the steering wheel?
Yeah, it's not your typical steering wheel.
For such a big rig, my God.
For probably one of the largest vehicles, this is quite a small steering wheel. The steering itself is, of course, it's all electronic.
Yes.
And what's happening with this wheel is when you're turning it, it's sending a signal back to what we call our PLC, which is Programmable Logic Controller.
Okay.
And it takes that signal, sends another one out to some hydraulic pumps that in turn move these large cylinders out here. And the cylinders themselves move the trucks back and forth.
Sure.
And of course it steers itself down the crawler way as to, you know, depending on what kind of degree you put in.
Is that how you control the speed?
Exactly. This is just like a foot pedal, you know, a speed pedal in the car. What you're doing here is you just increase the spot control, and it takes those. When we looked at those generators back there, it excites those fields.
Yes.
And by exciting those fields, we can adjust the speed of these propel motors down. And then along with the gas pedal, you know, you got a transmission. It's just like a car, forward, neutral, reverse. The other thing that the crawler operators are always worried about is its height, because one of the basic operations of the crawler is moving the mobile launch platform out to a set of columns, setting those down and moving out from under it. So he's always aware of what his height is, and he does it here by this average height here.
It's been a pleasure. It's a lot of fun. Thank you so much for bringing us around today.
We enjoyed it, Johnny. We're glad to have people come out and take a look at our machine.
Definitely. This was a lot of fun. You're watching NASA 360. We'll be right back.
Wow, that crawler, it's huge. To give you a better idea of just how big that thing really is, listen to this. Those tracks that they use each have 57 shoes, and those shoes weigh nearly 2,000 pounds each. All right, let's switch gears a little. You may have heard of something called the thermal protection system on the shuttle. You know all those black tiles along the bottom? You may also know that they help shield the craft from the 3,000-degree re-entry heat when it comes back into the Earth's atmosphere. But do you know what they're made of? Well, it's a pretty cool story. Johnny is over at the Thermal Protection System facility to see how the process works.
Okay, so we're here at the Thermal Protection System facilities with Martin Wilson. How are you?
I'm doing great.
Good to see you.
You too.
And this is where tiles begin life, right?
This is the part of the process where tiles begin. You know, this object right here is called a tile production unit.
Okay.
Weighs about 3 pounds. Yeah. It's a very low density material, rigidized fibrous ceramic, capable of withstanding around about 2,400 degrees, over 3,000 for very short periods of time.
Sure.
And we make these billets, as we call them in here. We start off with several different types of ceramic fiber that are all pre-kitted and pre-weighed. Yeah. These materials are put into this blender that we have over here with about 25 gallons of water and various chemical additives, ammonium hydroxide, silicon carbide, other surfactants and what have you. We put them in this machine and basically turn it on, and it blends the fiber for around about 12 minutes.
Okay.
And after the blending process is done, we go ahead and we put it in this casting tower over on the other side of the room. This device here is called a casting tower, and it's really simply a hydraulic press. We have around about 25 gallons of the prepared slurry, which is the chopped fiber, water, surfactant, and the other additives.
Sure.
And we now go through the process of loading it into the press. And despite many years of high-tech methods of getting the slurry from the bucket to the tower, this is how we do it. It actually takes about 25 gallons of water to produce one block. And actually for the CEV, for the Orion, we're using this. That's actually what this is for. Because these tiles are very light.
Right.
Extremely resistant to micrometeorites, and because of the trajectory of the new vehicle, it's going to see some pretty high temperatures, but for fairly short periods of time. And now they start this gradual dewatering process, which actually takes a little while to do. This stage of the process, the billet's been pressed. The next step is to actually extrude the billet out of the tower. At that point, it'll be taken to the other end of the building, dried for 16 hours at 250 degrees, and then ultimately fired in a kiln at 2,450 for several hours, and that will give you the block that I showed you to start off with.
So we are in a new section of the building. Why don't you tell us where we are and what do you do here?
Well, this is the machine shop, and this is where the actual base tiles are machined out of the billets of material that we produced down at the other end of the building. There's several different ways we can do that, but primarily all of the tiles are machined using diamond-coated tool steel cutters, either on a manual machine, which is called a tracer mill. The majority of the tiles we actually produce on these machines back here. This is a 5-axis numerically controlled mill. They use these type of tools. These are diamond tool steel cutters. This machine is highly automated. The program originates back in the numerical design area.
Okay.
The entire process takes about 20 minutes.
Sure.
In the beginning, we'll start off taking a series of rough cuts just to take the bulk of the material away, and then there's a series of smaller and finer tools that will come in and start to take those surfaces away.
So once they come out of the machine shop?
Yes, the next step of the process is to actually apply a series of ceramic coatings. The materials themselves, at this point, do not have a lot of strength. So we put a coating on. It's either a black or a white coating, depending on the emittance properties required of the tile. And it's put on in several layers. We make the coatings in here. They're basically very finely divided ceramic powders, either in alcohol or water, with various thickening agents and emittants and pigments. They're all sprayed by hand. The coating goes on in basically a 3-step process. But again, it's one of those processes that is very exacting. a lot of weights and measures to make sure the coating is of the exact correct thickness. This is the step that follows the application of the coating that we just saw. The coating has been applied and dried for several hours just at room temperature.
Sure.
But for the coating to consolidate or sinter, it has to be heated at 2,200 degrees for 90 minutes. That's what we do in these kilns. And we have a tile in here that's been undergoing that sintering process, and we can go ahead and take it out. The tile's at 2,200 degrees, and you'll be able to see how the black coating starts to cool down very, very rapidly.
Yeah.
Now this is just raw, uncoated material.
Sure. Look at them, they're glowing inside.
But those you can actually go ahead and...
These you can pick up?
Yeah.
These?
Yeah, you can just go ahead and grab them.
Are you kidding me? Am I doing it right?
Yep. Just pick them up by the corners.
I'm so afraid to. What's that? I'm afraid to.
As long as you just handle them only with the lightest of pressure.
At the lightest of pressure.
You can go ahead and pick them up.
This is so cool. It's 2,000 degrees.
Yep, it's 2,000 degrees. It's cooled off fairly quickly on the corners, you know, and that's the reason you're able to pick it up. It's still 2,200 degrees in the middle. You know, it will burn you if you're not too careful with it.
Of course.
But it is silica, it's very low density, and has a relatively low heat capacity, which is the only reason you're actually able to do that.
So, tell me, how does the shuttle tile work?
Well, in its simplest terms, a tile like this one here is really just a very, very lightweight, but a super insulator.
Okay.
I mean, you can put heat to one side of it, and eventually the backside of the tile will get hot. But for any type of re-entry vehicle, you know exactly what re-entry consists of. So you know approximately what the heat loads are going to be, so then it's just a question of designing the tile to be of the correct thickness. And I can actually take this tile and heat it up with a blowtorch, and you can see quite rapidly the surface will get up to about a little over 2,000 degrees with just this propane torch.
Okay.
But the actual heat is soaking through the tile very, very slowly. I could stand here for probably around about 20 minutes before the back of the tile becomes uncomfortably hot and I'd have to put it down.
Really? It's not hot now? On the other side?
No, it's not hot at all. I've got my finger right on the back side of it and I can't feel anything. It's probably going to take about 7 or 8 minutes before it starts to warm up. So yes, you can put your finger on the back of it.
Yeah,
it's just nothing.
Nothing.
And basically that's how most of these ceramic insulating strategies work. Just very, very lightweight. They delay that heat pulse.
Yes.
And you know, can be used for any re-entry vehicle, be it an Earth re-entry vehicle or a one entering Mars or any other planet.
So when you think of space flight, one thing you might not immediately think of is parachutes. But let me tell you, chutes really are important. I mean, they return the solid rocket boosters back to Earth. They help slow down the space shuttle on landing. And they will be used again when we phase out the space shuttle and begin flying our next generation space vehicles. Johnny jetted over to the parachute facility to find out more.
Okay, so we are here at the parachute refurbishment facility with my buddy Terry. Terry McGoon, how's it going, bro?
Good, Johnny.
Good to see you.
Glad you could stop by.
Thank you. Tell me, what are we doing here?
Okay, what we're doing here is this place manufactures, refurbishes, repairs, and packs the parachutes for the solid rocket booster first stage vehicle for the shuttle program.
Why isn't the chute solid? Why is it like this?
When you see the parachutes fly, they appear solid.
Yes.
Ribbon parachute like this withstands the heavy loads and the high dynamic loads much better than a solid parachute would. If you try to put a solid parachute out with this much drag at the speeds that we're going out, you'd probably tear the parachute up. The boosters themselves, the white structures that are on the side of the shuttle system, they come back and are reused time and time again. They're certified for up to 30 flights. So, you know, we're still using the boosters every time again, so we don't build a new booster every time. We integrate the pieces into a new booster every time.
So what are these parachutes made of?
The major component, in fact, almost the only component of the SRB parachutes is nylon. The ribbons are fairly strong, but not that strong. These are good for about 1,000-pound tensile strength if you were to tear it in this direction.
Okay.
A little bit more strength here because the load on the parachute is carried by this part, and this just creates drag and holds the structure together.
how big of a space can this this incredibly long parachute pack into?
Yeah, this is a big parachute.
Yeah.
And this parachute's 136 foot across at the bottom when it's fully inflated.
Right.
And we pack it into a bag, and the whole packed parachute weighs about 2,000 pounds, 2,200 and change.
Wow. Now check it out. We got a couple guys working on one right now.
Sure.
Yeah.
Well, we got Tom Gilliam and James Morrell
What's up, guys?
that are working on the parachute, getting it put in the deployment bag here.
Sure.
And as you see, what we've got, the deployment bag is inverted, and they're stuffing the parachute in vent first into the bag.
Okay.
They fold the parachute very carefully, and then lay it into the parachute deployment bag very carefully, and they tie it in all over the place with all of this 350-pound cotton webbing.
Sure.
When the parachute comes out, it pops out like you or I would pop a thread, and that makes sure that this parachute streams out and inflates correctly every time.
But let me ask you something. When these parachutes are deployed and they fall into the ocean, I mean, what do you do with them?
Okay, they fall into the ocean, and there's marine operations that goes out, and there's 2 ships that go out. One recovers the parachutes off of each booster.
Okay.
The divers go and they get them, and they put them on big reels on the back of the parachute, bring them back to us. We bring them back here and we rinse them. We don't really wash them because there's no detergent or agitation, but we rinse them out so that you get all the minerals out of it. It's seawater, it's got minerals in it. If you let that dry, it creates a crystalline structure, gets a sharp edge, and it'll mess up your parachute. It'll decrease the strength of the fibers.
Sure. So Terry, obviously there are like a million things that have to go right, you know, but this is like one thing that most people don't even think about.
Right, this is just one parachute of the parachute system.
Yeah.
This is just one process of the recovery system. The recovery system is just one process on the solid rocket booster. The solid rocket booster is just part of the shuttle system. And of course, once the shuttle system gets up, they have the orbiter that goes up, does the mission, and comes back home to do it all over again.
Amazing.
It's a very complex process. I'm really glad to be part of it.
Well, you know, Terry, thank you so much for your time.
You're
See
welcome.
you around, all right?
Yes.
All right, so we've scratched the surface a little to show a few of the things that are happening at the Kennedy Space Center. But you know, when our next generation space vehicles start flying in a few years, we'll start a whole new chapter in the long history of the Kennedy Space Center. So in the upcoming years, NASA personnel will continue working hard to reach our new national goal of getting us back to the moon and onto Mars. And guess what? All of us, we're going to have a front row seat for it. That's it for this episode. For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.
And one of the main goals is to get us ready to go to space. That's not right.
Johnny is at the Thermal Protection Facility Systems. This
is where all the most important... I'm talking about just getting it ready to fly. So, thousands of people must perform. So, yeah. And if you flip it over, it's... Look at this. Or you do this. not to mention hundreds of others. But let me tell you something. I was gonna say it ain't easy. Sorry.
For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360. I don't even know my name. That's it for this episode. For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.
La The time is now 5:03, and I'd like to call this meeting of the LaVergne Library Board to order. Today is January 13th, 2025. Our first order of business today is our board appointments, and as I am not your normal host this evening, I would like to open the floor to any nominations for a board chair.
I'll nominate Glenn back to chairman for rejoining the board.
I second. Okay. With a motion to nominate Glenn and a second, all those in favor say aye.
Aye.
Any opposed say nay. The ayes have it. Glenn, congratulations, and you can take it away.
All right. The next order of business is to appoint a library board vice chairman. And do we have any opening nominations?
Well, then I will nominate Leslie.
All right. I'll second. All those in favor?
Aye.
Any opposed? All right. We have Leslie. Congrats. All right. We'll go on into the minute.
I got so excited to chair the meeting that I skipped over approving the meeting minutes.
Well, we can go back and do that, right?
Yes, we
can.
can.
We'll go back and we need to approve the minutes for the November 4th, 2024 regular meeting. You should have a copy of those in front of you. Have a motion to approve the minutes?
So moved.
Second?
I'll second.
All right. All those in favor?
Aye.
Aye. Any opposed? All right. The minutes are approved. We'll move into FYI and updates, and we'll start with glad we started with that one and get it out of the way early.
Absolutely.
The vandalism that we had on December 13th at the library. And do you want to go ahead and just talk about that? And
I think you tend to know a little bit more about it. I'll just start, and then if you could fill in for me. So on December 13th, most of you have heard or have read about the vandalism and break-in that we had at the library. It started around 9 o'clock
p.m.
and yes, in the evening on that Friday night, and our visitors stayed with us until about 2 a.m.
2 a.m. Yep.
The most damage that was done was to the back door. A very large stone was thrown through the door, skidded across the floor, and hit our circulation desk. And I'm going to let Glenn, because Glenn pulled the footage for us, which we really appreciate, and we appreciate all the great cameras that we have in there. So Glenn, if you'll just fill us in with just highlights.
Yep, he came in that door. Well, he walked around the library for a little bit, just looking around, and then he broke the door at around 2 and came in, and then looked like he apparently went over into the gallery area and slept for a while, because he didn't show back up until probably about 1:30ish. And then he just roamed around the entire library, opening every drawer at every circulation desk. He tried to get into the back offices, but they were locked, and he didn't try to break anything. Luckily, he just went on his way. And then he went out the double doors to the lobby, and he tried to prop the door open. And little does he know that the stopper on that door is not good, and unless you wedge it in a certain area, that door will shut. And so he went to the bathroom, and the door shut, and it auto locks. Okay. So he locked himself out, which I thought was nice. And so he tried to get back in. He ended up going out the hallway, exit door, walking all the way back around the library, coming back in the back door, went and got his stuff, left through the front doors of the library, and then went over to the 7-Eleven to apparently try to steal candy bars. So pretty lucky that that's all that happened. Yes. You know, he was in there a long time and could have done a lot of things. So, and as part of that too, we have a quote already for a burglar alarm at the library. We talked with Donna about that. It's I think it was about $5,000. Yes. It came in a lot cheaper than we expected.
So we'll be moving forward with that just as soon as we get all the approvals and things like that done. So.
Thank you, Glenn.
And he was caught.
Yes. To my knowledge, he turned himself in, but they were very hot and heavy on him, and thankfully for all the public that put out the word and shared the post that the LaVergne Police Department had put out. So he was in custody.
Wonderful.
So, and like Glenn said, there could have been a lot of damage. He could have even just gone through and knocked all the books off the shelves. Of course, any money that we have was locked up in the back offices, which I teasingly say that we're like Fort Knox, but I'm so thankful that we are, because at night there are certain doors inside that we do lock, and that worked out well. The new door is on and looks great, nice and clean.
Come see that.
So that was great. The tiles, there wasn't a lot of damage to. So all in all, we were fortunate. The biggest damage that was done was that we had to cancel our Santa visit for that Saturday, because when he came through the door, burst the glass, he walked through the glass and then he walked all over the library. So we had glass everywhere. And so that's why we had to cancel, but we did reschedule. And like Glenn says, we do have Turner Security, who came out, gave us a good quote and a very good monthly amount, so it's not going to cost that much. Turner Security does our fire alarm system, so we feel very fortunate for them to come out and help us out in that way. And for 22 years, this is our first major thing, so I feel very fortunate for that.
Yep.
Okay.
All right. Let's see. You just want to go ahead and continue with
Sure.
the agenda there?
All the rest of this is our FYI for your information and some updates. Our Saturday, December the 14th. Nope, it was the next Saturday, the 21st, correct? That would be 7 days. We had Santa at the library. We had a story time to begin with. Thank you to Alderman Haas, who came out and joined us for our story time and for our visit with Santa, and helped us give out our goodie bags. We had approximately 244 in all. I think we had about 105 in our story time, and it was a lot of fun, and Santa was in rare form and had a very good time with the children. So it worked out wonderful. And also a big kudos to JJ from the fire department. He came out, and his photography skills are amazing. Still have not got those pictures out on Facebook, so we're working on that.
And there was one other special guest.
Oh, yes. So we had the Grinch. The Grinch came, and of course, he is wonderful with the children. He did a great job with entertaining them, and it's kind of funny. A lot of children love the Grinch just as much as they love Santa. So that worked out good. And we also had an elf for story time, Danny, who did a great story. So we appreciate that. We have our book sale going on now. It started January the 2nd through February the 1st, or until we sell out. We still have quite a few great books that have been donated to the library. Books are very inexpensive, 50 cents for hardback, 25 cents for paperback, and all children books. So would love to have everyone come out and peruse our books. I apologize. The next thing I want to talk about is story times. We have been going back and forth with our story times since Miss Lorna has retired, and we do not have a youth services coordinator. So it's been a little bit difficult. On Mondays had been just our homeschool story times, and we would have various ages in there, so it was very tough to stick with like a specific science or math or something of this sort. So we have decided that we are merging the Monday and the Wednesday story times. Now, Wednesdays was preschoolers, Mondays was homeschoolers. So now we're going to have on Wednesday at 10 a.m. all together now. So I'm going to be doing a family story time. And the Wednesday story time is one that I had started after Lorna left, or I had taken over. And it works out really well. We're going to do a lot of intergenerational activities. We're going to do stories, music, movement, arts, crafts. And my goal is to use the older children who come to the story time so that they don't feel like, oh, this is real babyish for me, to help out with the youngers. We're going to partner up, kind of be like a big brother, big little sister, or vice versa. So I'm looking forward to that. I love the theme all together now, because that seems to be a big theme at the library. We have families who come with a baby all the way through 12-year-olds, and they may be homeschooling. And so you have all of those ages in one room, and you're wanting to reach each one. So it's going to be challenging, but it's going to be fun. We are sticking with our books and babies, though. That's Miss Sherry's story time. That's on Thursdays at 10 a.m. It's for ages birth to 24 months. This is a lap sit program. I say lap sit very loosely because they are all over the room. But it's so much fun. And it's just introducing early literacy. She uses a lot of nursery rhymes, a lot of poems, music, movement, very short board books, and just a great way to set examples for the parents on how to read to their children, even to the little bitty ones. And it's a very popular program. And then I wanted to just bring it here because it's in February and we won't see each other again until March unless you come over to the library. We're going to have a special program called Dinosaurs in the Library. I had Struts Entertainment reach out to me back in November, and they are going to be in Middle Tennessee. They have 4 realistic, kind of short size, but realistic looking animatronic dinosaur puppets. And so they teach in a very educational, fun, and high energy way. So we're looking forward to that program. We're doing it on a Tuesday night so that we can possibly bring in more families. And that will be February the 4th at 5 p.m. So I will be sure we'll be getting that out on Facebook. We'll be getting it out to everyone. And before we go to the library board schedule for 2025, I would like for you to pull your schedule here. If you will see on the back, children's story times. Of course, our first one is going to be the 22nd. We are waiting until after Martin Luther King Day to do the first one. And that will be the 22nd and 29th of January, all together now for all ages. And then the 23rd and 30th would be our books and babies. And I love the blurb. Discover the joy of stories, songs, and community at our all-new, all-together now story time, perfect for all ages. This inclusive event brings everyone together to celebrate the magic of storytelling. And I know, Carissa, that clicks with you, being our librarian. And then you will see the different events that we have going on. Tonight, we have going on right now Lego Fun for ages 5 through 12 and Strings and Things for ages 18 and over. So as you can see, we do a lot of things for a lot of people. Okay, Glenn, would you like to go over the library board schedule for the rest of this year?
Sure. The 2025 library schedule as follows. Today is the 13th. The next meeting will be March 10th, then May 12th, July 14th, September 8th, and November 10th.
Okay, and I appreciate you all. And as I have said before, my goal is to get these agendas out to you early, and that includes you, Jerry, so that Jerry can do his job. Thank you for bearing with me tonight, and then I'll turn it back to Glenn.
All right, we're down to library board comments. I'm sorry, I don't know everyone's last name yet, so Ms. Clear.
Yes, sir. All right, so as always, Ms. Donna, the library does a fantastic job, but I also want to highlight how our city supports you. So we are very fortunate in LaVergne to have our city government support the library and understand the importance of literacy and what that library does for our community, the doors that it opens. So just can't say enough great things about LaVergne.
Thank you. And we want to let Carissa know that we are keeping her and the libraries in the schools in our prayers for some things that they are going through right now. And we appreciate you advocating for the children.
Thank you.
Alderwoman Haas.
This is my first meeting. I look forward to joining the library board and joining the events at the library. I had a blast at Santa.
Good.
And the reading, I don't think I can do the babies, but the older kids and stuff, I'm looking forward. And of course, being
Right.
retired gives me the flexibility to come out and do things. So I look forward.
We look forward to seeing you. Thank you.
I wanted to first of all say that I'm first of all, I'm very sad about what happened with the vandalism and the break-in and everything, but the resilience that the staff has shown is very impressive, and I just wanted to acknowledge that. I know, having experienced something like that personally, even at work, it can be jarring, right?
Yes.
And emotionally, so just wanted to acknowledge that. And then I also wanted to say, lately I've been mainly using, electronic books from the library, but I had to come in and renew my library card, so I better show my face, right? And I just wanted to say that it was delightful. I mean, all I did was go in there and renew my card, but,
Great.
just the smiling faces and friendly folks were wonderful. So thank you to the staff for that as well.
And thank you for telling us this, because sometimes we don't get to see how the interactions are, even though I know we have a fabulous staff. So that's always very meaningful. Thank you.
Sure.
I'll just say I'm just tickled to death to be back on the library board after sitting out the mandatory 4 years. And thank you all for electing me the chairman. I appreciate that. And just looking forward to a great year, and I know we'll have it.
Absolutely.
All right. Anything else?
You get the gavel.
Oh.
Yeah, will you call the meeting adjourned, please?
All right, I will call this meeting adjourned.
Thank you all.
Won't you take me back to Tennessee?
The award-winning Tennessee Wildcast is on the air with the latest info about hunting, fishing, boating, wildlife watching, and all things outdoors. This episode is brought to you by GSM Outdoors, whose vision is to preserve the sportsman's legacy, fuel innovation, and enable the next generation of outdoor enthusiasts. Think outside. That's where you'll find us. Now, make welcome your host, Jason Harmon.
Hello, everybody, and welcome to this edition of Tennessee Wildcast. We're glad you're tuning in. Thanks for watching. Thanks for listening. We got a great show lined up for you today, and we got a full house here in Studio B in Nashville, Tennessee, and Mr. Matt Cameron is helping me co-host. How's it going, Matt?
Man, this is the warmest I've been in 2 weeks, bro. It's like it's been single digits.
Yep.
And in this room here, we're all nice and cozy. So, man, I'm here. I'm ready.
You got a cold joke for us?
Man, I talked to my friend who lives down in Louisiana. He tried to duck hunt last week, and they had all that snow. He said the ducks came in, and it was cold. They turned around and started flying back north for the winter. And he said some of them tried to land, they froze to the swamp, but when they got up and tried to fly off, they took the swamp with them. So now they ain't got a swamp left to hunt. Crazy.
Wow. Yeah, that's some crazy stuff happening around here these days.
Yeah.
Well, that's the voice of Matt Cameron, and normally Matt's with me in Region 4, East Tennessee, but we got a special show for you today coming out of Nashville, and we got a group of great folks here with us today to talk about some events that happened back in September and with Hurricane Helene and some of the things that are still going on. So anyway, just wanted to give you that intro, but first I want to cover a radio station. We always appreciate our radio stations for airing Wildcast across the state from Bristol to Memphis. You can hear this show, and the station today is WJDT out of Morristown. They air Wildcast at 5:30 a.m. on Saturday morning. So we appreciate WJDT out of Morristown. And again, we appreciate all our radio stations and radio partners across the state. If you watch, listen, make sure you subscribe. Subscribe from those different platforms where you find our show. Our partnership with GSM this year, we're going to be giving away a lot of prizes, so it's important that you like, subscribe, share, comment, all those things. Engage with us so that you can get your name in the hat for some of these cool prizes from GSM Outdoors this year. And check out all those brands at gsmoutdoors.com. All right. Well, today we've got Shelly Hammonds with us, our new Lieutenant Colonel for the TWRA. I'm glad you're here, Shelly.
Thank you.
We've got Jeff Prater, and he's our Region 4 Lieutenant out of East Tennessee. Justin Pinkston, Wildlife Officer in East Tennessee, and then you've heard from Matt already, our Communications Coordinator and Officer out of East Tennessee. So we're happy to have you guys here with us today and excited to have this conversation and just reflect on some of the events back in September and just kind of get it firsthand from you all and share it with our Wildcast audience. But you all recognized at a commission meeting in Memphis with the Valor Award, all four of you, for your efforts in the rescues and things that happened during those events of Helene. So thank you for your service. Thank you for your sacrifice. Appreciate that very much.
Yes, sir.
Let's kick it off with Shelly. Shelly, you just recently took the promotion for Lieutenant Colonel.
Yes.
And you've had a lifelong career with the agency in many different aspects, different positions, and just share with the folks a little bit about your career and kind of how you got to where you are today, and then we'll dive into some more stories and things.
Okay. Well, I started out in 1997 as a county officer in Rutherford County. And
right here in Middle Tennessee.
Yes.
All right.
Yep. And about a year after that, I was able to transfer back home. I'm from East Tennessee, and I was able to go to Cott County, where I spent the next 16 years as a county wildlife officer. You know, I was blessed with a lot of good people to work with, a lot of good people that trained me.
Mm-hmm.
My old partner in Cott County, we were partners for, 12 years maybe.
Yep.
And
give him a shout out.
Scott Hollenbeck. Yeah, he is a legend. He is a legend. And, you know, God bless me with a lot of good people in my life to help raise me to where I am, I guess.
Yeah,
you know,
yeah.
Give me things that I should never forget. And so then I promoted to the regional lieutenant position in Region 4. And in 2020, I was promoted to the major position, and then just recently, Lieutenant Colonel.
Very cool. Very cool. Are you the first female lieutenant colonel for the agency?
Yes.
Yeah. I think that's awesome. Working your way up, and it's very cool for you to achieve that position. And you're a great influence for the agency and all those people who work under you, and great leader. So
It's kind of you to say.
yeah. Congratulations. I can remember back when I first started with the agency, looking back at some old Wildside footage. I believe you were out working some bear hunts and things like that. So we have to dig that footage out, Todd, and add that.
Please, by all means.
But so that was, those were cool things to look back on and see you working out there. I didn't get to work beside you in many events, but, good work.
Thank you. Thank you. I've had the time of my life. I can tell you that.
She's got some other special certifications that you would think wouldn't play into being a wildlife officer, or much less a major or lieutenant colonel. Would talk about the other certifications you got really quickly. Don't spend too much time on it, but I think that helped you get into coordinating a lot of our training and just helping us be more effective as wildlife officers and sometimes rescuers in the agency.
Yeah.
Sure. Yeah, I have a registered nursing license and also a paramedic license. So.
And 2 master's degrees.
Yes.
And a wildlife.
You're just going to pull it all out of her.
But man, she's gassing her up, man.
Yeah.
She doesn't need that, but I just want y'all to know that she went above and beyond to get to where she's at. She didn't just do the status quo and get promoted. She's the real deal. Think a lot of her as a sister.
Mm-hmm.
We pick at each other quite a bit, and I'm usually on the other end of that. I'm just kidding. But at any rate, no, I grew up in Jefferson County. I hunted in Cotton County quite a bit, in Rankin Bottoms. That's where I saw her for the first time. I'm like, wow, there's a girl game warden. It was the coolest thing, you know, back then. She never wrote me a ticket or anything either. So God bless her for that. No. But anyway, thank you for allowing me to tell you a little bit more about her. We're very proud of her.
Well, thank you for pulling those little tidbits out. We needed to share that. While we're doing it, let's just go ahead and jump into Jeff. Jeff, tell us a bit about yourself. We need to get a little full background here. I don't want to skip anybody.
Yeah, so I started as a part-time boating officer back in 2001, and I'm from Middle Tennessee as well. So I was on Center Hill Lake for a couple of years before I hired in full-time. Went off to Carter County to start my full-time career. Stayed in Carter for about 1 year. When I got off probation, I transferred to Washington, stayed there for about 9 years.
Mm-hmm.
When we restructured in 2012, I became a sergeant in District 42. A year later, unfortunately, our lieutenant, Gary McWhirter, passed away, and I filled his position. So I became the district lieutenant in 2013, and I stayed there until 2020 when Shelley moved up. I sort of come in and filled her shoes as a regional lieutenant. So.
Awesome. Well, thank you for your work and your dedication to the agency. Justin, tell us a bit about yourself, and then we'll jump into some of these stories and stuff.
So I started in 2019, so I'm on my 6th year. I was hired to Jefferson County. I'm from East Tennessee in Greene County, so it's nice to get close to home, but not right back in home.
Yeah. Some of those times, it can be hard to work in your home county. I mean, you know a lot of people, and
everyone gets treated the same.
Yeah,
right or wrong.
That's a way to look at it.
Mom's fishing without a license. We'll do business.
Wow. You heard that, Mom.
Wayne Rich at his retirement, his mom was there, and they said Wayne Rich is the kind of guy who would have written his own mom a ticket. She was there, and he said, I'll never see my mama fishing, or I probably would have.
Mine knows better, so if you're going to break the law and you know me, you know what's coming.
Hey, Justin is Officer of the Year as well. Talk about that real quick.
Last year I was selected as the 2023, well, I guess it was rewarded last year, the Secure Safari Officer of the Year. I'm extremely blessed to have that.
Awesome.
And fun fact, talking about Jeff used to be my lieutenant, made my first bait case with Jeff, turkey bait case. So
yeah,
pretty awesome. Unique connection there.
Yeah. Well, and y'all continue to work together real closely, and we'll learn a little more about that today and some of the events that we'll cover. But anyway, so today is all about Hurricane Helene and some of the events that happened back in September. And I'm just going to throw out a few stats here, and then we'll dive into some of these stories. But during that time, there was up to 9 inches of rainfall in the area. The Nolichucky reached a flow rate of 84,000 cubic feet per second, which is typically around 500 to 600. The river was estimated to be rising at 2 feet per hour. Close to 1.3 million gallons of water was pouring over the Nolichucky Dam each second. The quick rise in the water level surprised a lot of people, leaving a lot of people stranded, and that's what we're going to kind of cover today. these folks that are in front of me played a huge part in rescuing a lot of people. And we're going to hear those stories today and touch on some of that. But if you want to see some of the more longer stories or full video and some of the stuff that we've put out about this, you can visit our YouTube page and see some of that intense footage of these rescues. We'll also have some of that on this show, so if you're watching, you'll be able to see some of that footage. But our TWRA officers go above and beyond and stepped up in this event and have saved a lot of lives. And Matt, I'm going to turn it over to you and let you kind of kick this off with that first rescue that you'd mentioned that you wanted to cover today, and kind of get it started there, if you don't mind.
I will. I'll probably pass the mic rather quickly because it's all, and you're going to hear this a lot. There was a lot of divine intervention that played out that day to make things work out for God's glory and for our good and for the people that we were sincerely trying to help. So when I arrived at Dave Fender Road, and they'll have to tell you how we all kind of ended up at that spot, these three were already gone in a boat making their second trip to go after somebody. And you talk about a feeling of disappointment when I saw them leaving. I call it the shoreline, but this is a field. The flood had backed up into these people's farm right here. They're leaving to go back out. I'm like, I'm supposed to be in that boat. Why did I not make it? Why did I tally? Whatever. The reason I wasn't there was the man that they rescued and his two dogs were rather heavy. And had I been in there, we could have been going down toward that Nolichucky Dam that was spilling 1.3 million gallons of water. So
yeah,
it worked out for the best. Everyone was rescued, but I'm going to pass it off and let them tell you kind of how we ended up at that spot, because it was, I don't think any of us left for work that day thinking we're all going to Dave Fender Road and we're going to perform some rescues.
Yeah, jump in, don't be shy, and share, and let's share that story.
Okay.
And everybody's looking at Shelley.
Everybody's looking at me. So yeah, that morning, I wouldn't say it started off like any other morning for us, because we knew the rivers were going to rise. They always do, and we knew how much water was dumping in North Carolina, and our rivers come from North Carolina, and so the French Broad, the Nolichucky, and the Pigeon, and so I think everybody was just kind of, we knew it was gonna rise, but what did we need to do? And so a lot of people are already out working. We had a team of call out around, I don't know, I want to say about noon, 12:30, something like that, and they wanted our officers to bring boats to Unicoi County, to the Unicoi County Hospital, to Irwin, to the Unicoi County Hospital. They needed to rescue a lot of, patients and workers that were on the roof.
Because that was flooding.
It was totally flooded, yeah. The word I had gotten was the military vehicles could go in like 7 feet of water, maybe. And this was already 15 feet of water.
Wow.
So nobody could get in there but boats. And so about 5 minutes later, they called us off. So put that out on the radio that, it's a no-go right now. And then it was probably 25, 30 minutes later, we got the call again. Y'all have to go. So everybody just kind of started headed that way. I think Jeff would have been the first one to get there. One of the first ones anyway to get there, just due to his location, proximity there to Irwin. And so he was headed on his way, and I heard him on the radio talking with dispatch about someone flagging him down, that some people were in a house, on top of houses, in a house, needed rescue.
So you're headed to the hospital, and now you've been redirected to this house.
Yeah. And this was kind of it was on the way for me. If I was going to Irwin, I would take 107 to get up there. Jeff took 107 to get up there. Justin probably would have came the same way, and Matt. So we all would have gone through that area. We didn't really divert to go there. But once we got to that area, we stopped, and Jeff shared his location with me. I met up with him probably 20, 30 minutes later, maybe, after everything was going on. And then Justin had grabbed a boat. He was headed that way. Maybe another 15, 20 minutes or so after I had arrived, Justin got there. And we just jumped in and went. Matt was headed that way. He had called me and asked if he could do anything to help. I said, come on. I don't know what we're going to be into, but just come on. So
yeah, starting out your day, you had no idea what to expect, or what would be ahead of you. And what was going through your mind though as you were on the road headed towards the hospital, and just what were you thinking at that moment? Like, I'm sure you're mentally trying to prepare for what's ahead. You don't really know. You've heard some reports maybe, but what was going through your mind at that time?
my mind, I was just thinking, I don't doubt our guys' training, but please let them go home tonight to their families.
Yeah.
I mean, that was my heaviest thought.
I think for me, living in and around the river, I think people become complacent with flooding. They're used to floods coming up. And I think some of that created the situation where people refuse to leave. And so I was sort of thinking about, this is just probably going to be one of our average floods. I didn't think it was going to get to the extent that it did. And of course, I was headed down Highway 107 toward the hospital, and I got flagged down by a car. And they told me that on Dave Fender Road that there was at least 3 people and a couple of pets that needed to be rescued. And when I pulled down there, I was pretty shocked at what I saw. The water was way out of the banks, probably, I would say, close to 400 or 500 yards out of the main channel. It had already taken some homes on that road. And the most frustrating part for me is that I was there to help and had no ability to help. So I'm there without a boat. I'm, of course, talking to, at the time, Major Hammonds, Lieutenant Colonel Hammonds now, keeping her in the loop. I ended up talking to Justin and saying, hey, can you get down here? We've got a live rescue that needs to go on. And so I was talking to the guy on the phone, and he tells me right off the bat, I've got almost no battery left. And he's telling me what's going on, where he's at, and I'm like, we're coming. But little did I know it was going to be, it felt like an hour. I'm not sure exactly how long it took, but I'm sitting there, people are staring at me, wanting me to do something, and can't.
You just can't do it, yeah.
Yeah. So ultimately, Shelly shows up, and that kind of gives me a little bit of relief. I'm like, okay, I've got somebody with me now. And then we're waiting on Justin to show up with the boat, and maybe.
Yeah, I was coming from Jefferson County, and I'll give a shout out to my partner, my boating officer, Hunter Wisecarver. He covers Cherokee and Douglas. I was like, I'm going to grab our jet, because I grew up in Greene County. We're used to floods. When it floods, it means we get to duck hunt. Yeah. Like, we've never had a flood like this. So in my head, I'm thinking, normal flood, I'm going to grab the jet. And Hunter radioed, he was in Cocke County helping with the flood already. He's like, hey, grab the prop. And I didn't want to take the prop, our prop boat in Dandridge, in case they needed it. He's like, hey, take it. And man, divine intervention, Hunter saying that saved our life, because we would have died in the jet. That jet wouldn't have been able to operate in that water. So went and grabbed our 90 prop and went up the interstate, and I could hear Jeff and Shelly talking on the radio about what was going on. And I was starting, family and friends were sending me pictures, and at a red light, I was able to look at my phone and see like the hospital picture. And I was like, ooh, it's a little bit different flood than what we're used to. I mean, it's halfway up the hospital, and it looks like something you'd see on CNN at night with a breaking alert. And I was like, this is pretty serious. So I heard Prater on the radio. When he called me, I was like, what do you need? Where am I going? Because I could tell it was worse. He's like, I need you to come Washington County 107. So I hopped off the interstate and headed that way. And I can't remember who. Someone said there was a house going down the river. And at this point, I could see the water backed up. I mean, it's 600 yards out of its banks. And I saw a 2-story house going down the river, not floating. I had to been doing 20, 25 mile an hour going down the river. And I'm like, all right, this is serious. And it really didn't fully set in until you get out there in a boat. But I trusted our training, and that I felt comfortable getting a boat out there in that water, but it was pretty swift.
And mind you, like Jeff said, this is 400 or 500 yards away from the main stem of that river. Had this been right on the main part of that river, it would have been a death wish to have launched probably a boat of any kind, a raft, inflatable, whatever, much less a rigid hull boat like we were in. We couldn't have done what we done had it not been so far away from the river. Water was still rushing pretty hard. Talk about all the crap that was coming down through there. You've mentioned it several times, the stuff that was coming by.
You could see it in the videos,
Yeah, just anything you can think of. It was picking up round bales. It was picking up garages, anything laying around, grills, anything. Cars.
Yeah.
Giant propane tanks.
Yeah,
hissing.
a lot of those.
The fabric in the fields from the tomato fields. And that was my biggest concern, was if anyone's ever drove a prop boat, you don't want to get something in your prop.
Oh, definitely.
And I was worried the whole time, like, hey, if this prop stops, we're in trouble.
So take us to that point. The boat gets launched. Y'all are in it. You're going out, not for Brian yet, the man inside the house, but you had to divert because you thought you were going out for him. Is that right?
Well, our intent was to go to Brian first. And when we got over there, Justin immediately noticed that I'll let you jump in there.
So we went to Brian's house first, and we kind of had to go upstream first because there was a lot of debris in the water, and come downstream. And then I had to drive past his house to come back upstream, because if you turn too fast in that fast water, it's going to dump our boat. So I kind of come up to his house, and in the video you can see there's about a foot left of chain link fence. So I'm trying to navigate all that and not get stuck in something, get caught in a strainer. So Prater was talking to Brian on the phone, and I think he was in the attic with his dogs, and we was trying to get him out. And while they were working on that, Lieutenant Colonel was holding on to the house. Prater was talking to him on the phone, and there's a grandfather and his grandson on top of this block shed beside of us, and I'm starting to see the water come through the bricks. I'm talking like 5 feet up coming through. I'm like, hey, that shed's about to go down. Let's get them. Their life is in imminent danger. Like 60 more seconds, I don't think they're going to be there.
Yeah.
So we pushed off, grabbed them, and I was hoping in that time Brian could get out of the attic and be waiting on us. And thankfully, we was able to get them in the boat and get them back. Turned right back around, and at that point, Brian had made it back down. But in the 2-3 minutes it took us to get back, maybe 5 minutes, that water had rose to level with that chain link fence. So it went up 12 inches in 5 minutes.
Wow.
You couldn't barely see the chain link fence. And then I'm going to throw it back to Prater, because I was just driving the boat at that moment. But we were having issues with the boat, and something I've not encountered. That water was so thick with silt that it was having trouble. The water pump wasn't cycling water.
Right. Yeah.
What us country boys call the motor ain't peeing. That's a bad thing. It's going to overheat. It wasn't peeing.
Yeah.
So I was constantly having to shut the boat off, rev it, and get all that silt out of the engine. So I was dealing with that the whole time. And while Major was holding on to a clothesline, I was keeping it like quarter, almost half throttle, just to keep us in place of how fast the water was moving. And then,
well, that shows the experience kicking in. You know, our officers know how to operate their equipment and are ready for, you know, whatever may come their way. That's awesome. So you jump out and you're going after this guy, right?
So as we approach the home, you can hear him beating on the door, and he's yelling, "I'm stuck, I'm trapped," something of that nature. And you can tell he's panicking. And of course, Shelly and I are in the front of the boat, and I look at her and I'm like, "Are you good with me going?" You know, and just to sort of give you a little imagery here is around this home, the water's just rushing around, but like behind it was like a little eddy. Like the home was creating this calm water. So when I got in, I'm thinking, easy, right? I'm just going to walk over here to the door. I'm going to get him, and we're going to go back to the boat, and we'll go to the house.
Yeah.
Right? Well, it's not exactly the way that worked. As I got over to the doorway, just trying to see what was going on with him, I reached up to try to grab the door to get into the home, and the whole door frame and everything came out on top of me. And behind that was the couch and everything else in that room. So it's sort of, I'm trying to walk on water, and I'm not doing a very good job of it. And it sort of flushed me back maybe, I don't know, maybe 20 yards. And what I haven't really told a ton of people, except the people in this group here, is there was a piece of like wrought iron furniture that was in that room. Maybe I sort of think of it as something a plant would sit on. My bootlace got hung around that, and it was holding me and trying to drag me. So I'm sitting back trying to get my lace off that stool or end table, whatever you want to call it.
Yeah, whatever it was.
Yeah. And eventually I get it off. I make it back up to the door frame, and somehow in that time Brian has got that door open and has made it down he's coming down the side out of the main flow of the water coming through the home. Let me back up to say, as soon as that door came out, the water was flowing hard.
Yeah.
through the home. And so he was kind of sidestepping that. And I asked for a life jacket, and I asked for a throw bag. So I threw him a life jacket. He just put it on. It was a horse collar. He put it on, didn't strap it or anything, just had something on.
Right, yeah. Do what you can do, yeah.
Yeah. So I threw him the throw bag, and he at this point is focused on the dogs. He's got a lab and an older beagle, gray-faced beagle. It would struggle to swim in that for sure.
Sure.
And as he come down through there, he tried to send the dog. The dog didn't want to come to me. So it swam down, turned around, went back. And so he sent it back. And when it come by me, I tried to grab it, and it made it by me.
Wow.
So I had to swim over and grab it. I took it over to the boat and threw it. Justin grabbed it and threw it in. And all the while, Shelly is hanging on for dear life.
Right.
So
holding that boat in place.
Don't minimize anything that she did. Yeah. She absolutely held us in place. I know Justin was bumping the motor, but at one point it died.
Mm-hmm.
So she was vital in this whole thing.
Like one hand on the piece of pipe clothesline and one hand on the boat, like holding at times the entire boat.
Yeah.
Yeah. To that house. So.
Yeah.
Like
we'll let you talk about that.
It's on video. You can see it.
So he comes down with the second dog, the older beagle, and it's got a collar and a leash, and he's kind of reaching out and said, do you have it? Do you have it? Well, I grabbed it. I couldn't reach the dog, so I grabbed it by the collar, and I thought, when it goes down, I'll just pull it to me. Well, it slipped right out of the collar, of course, and it goes under, and I just take off swimming. Takes me a little bit longer to catch up with that dog, but I get to the beagle, and I'm working my way back over to the boat. And at this point, Brian has made it to the doorway, and he's stuck. And I'll let you jump in again, Justin, here.
Well, we're going to pause right there because we're going to run out of time, but we're going to do another show. This is some great information and stories, and we want to keep sharing this. And we're going to do a part 2 if you guys will stick around for a part 2.
Absolutely.
And we'll continue the story. Don't be checking your watch. We'll pick this story back up. I appreciate everybody tuning in and watching and listening today. Keep coming back for part 2 for this show, and we'll see you next time.
Stay connected with TWRA by visiting our website at tnwildlife.org and follow us on Facebook, X, and Instagram. Join us as we celebrate 75 years of conservation in our great state. You can invest in Tennessee's wildlife future by purchasing a license at GoOutdoorsTennessee.com. That's GoOutdoorsTennessee.com.